Uh, Hi, everyone. Good morning. Welcome to our workshop for the Tier 5 rulemaking. Um, Today, we'll be talking about the averaging banking trading concepts, idle reduction concepts, and concepts for the onboard diagnostics as it applies to Tier 5 and off-road. Just some housekeeping for the questions in answering section later today. Here, there's some Zoom webinar details if you want to use the phone. So you could call in at this number with this access code. I'll leave the screen on here for a few seconds if anyone wants to write that down and use that. Otherwise, we will be using the Zoom raise hand feature, or you could type questions in the Q&A box. If you are on the phone, you can use #2 to raise your hand so that we see it here on the Zoom meeting. And you can use *6 when we indicate to do so to unmute and mute yourself. Here's the agenda that we have planned for today, where we have opening remarks from him, our branch chief, and Jen, our supervisor. Then we'll have a talk on the OBD concepts from Shabnam Dilmagani. We'll have questions and answers and discussion following that, followed by our lunch break. And then after we return, we'll hear from Jeff on ABT concepts, and then we'll have a Q&A section following that. We'll have a short break, and then followed by our last major topic, which is the idle requirements and concepts from Shun Nakao. And then we'll have a Q&A after that. And after the third presentation, we'll have a Q&A for all the topics if we didn't reach all the questions in time during the allotted time limits. In cases where maybe some of these sections run short, or there's not enough discussions to fill the, there's not enough questions to fill the time we had allotted, we'll move on with the schedule and then start other sections earlier as needed. And at the end, we'll discuss the next steps from Jenna.
All right, great. Thank you, Christian. Good morning, everyone. I'm Jenna Latt, and I'm the manager of the off-road control section. Thanks for joining us at our fourth public meeting to discuss potential concepts for the Tier 5 rulemaking. We appreciate your feedback and also the alternative concepts that we've received to date. Since the rulemaking process began nearly 2 years ago, we've had over 75 meetings with stakeholders and met and toured 4 manufacturing facilities with EPA in September of this year, listening to stakeholder feedback. So this has been a really important process for our team, and your participation really makes a difference. Additionally, we've received activity data from over 10 manufacturers, which has been extremely beneficial for the development of the low load cycle concept. So as many of you know, we're conducting a cost analysis on the incremental costs of new technology for Tier 5 using an outside contractor. And we've heard from them that they've received many responses to the cost survey and expect many more to come in. So please continue to send them in by the end of this year. So as Christian already mentioned, we've got 3 topics for today: onboard diagnostics, average banking and trading, and idle reduction. And the 3 slide decks for our meeting are posted on our Tier 5 website, along with all the past presentations. So if you go to ARB's website and you type in the search Tier 5, you'll get to our website, and then you click on meetings and you'll see all the presentations from today and from the past. In addition, this meeting is being recorded as our other public workshops, and that will be posted in a couple weeks. So you can look for that. And then one quick note, so this work group is a separate rulemaking process from the off-road in-use diesel fleet amendments that were approved by the board in November. and they're being handled by a different section in CARB. So just as a reminder, our focus today is on the new diesel off-road engines and is not directed at fleets. So with that, I'll hand the program over to Kim Rogalski. She's our chief of the Mobile Source Regulatory Development Branch. Kim?
Thank you, Jenna. Thanks so much. Good morning, everybody. And thank you so much for taking the time to attend this. The more input we get from affected stakeholders, the better job we can do putting this rulemaking together. And like Jenna said, we've had really, I would say, an unprecedented level of involvement so far, and it's been extremely helpful. So please keep talking to us and sharing data. I'm particularly excited to have our OBD team roll out their OBD concepts, because I know this is really something very new for off-road and something that manufacturers are very interested in. I wanted to note one administrative thing, which is we welcome your questions and comments. If you do want to ask a question or comment, please either raise your hand or type your question in the Q&A. If you type your question in the Q&A, we will be reading your question out loud so that the group can have the benefit of the question and answer. So thank you. That's all for me.
All right,
we'll
go ahead.
We'll start our first discussion and talk on potential off-road onboard diagnostics with Shubnam.
Good morning, and thank you for your time. Today, I'm going to talk about potential off-road OBD concepts. The focus of today's presentation is to share with you what we have come up with so far and to get your input and thoughts. Let's begin with the outline. Next slide, please. I will be talking about potential off-road OBD concept, objectives, overview of standardization requirements, diagnostic and certification requirements, and applicability. Next slide, please. The main objectives that we have come up with are primarily to support manufacturer-run off-road in-use testing and CARB-run in-use compliance program that includes the off-road REAL, data, and standardized communication. If you are not familiar with REAL, that stands for Real Emission Assessment Logging, and I'm going to explain that in more details in the upcoming slides. Also, to facilitate emission-related repairs, whoever has experience with on-road OBD knows that how much OBD helps the repairs, and we would like to incorporate that for off-road as well. Also, we would like to make sure that emission-related components are repaired during the warranty period. Apparently, when a malfunction is detected by the OBD system during the warranty period, most likely it's going to be fixed by the owner because it is covered under warranty. Also, we would like to enable emission control inspections. Next slide, please. In terms of standardization requirements, our current thinking is to include communication protocols, J1939 and J1979-2. Also, a standardization of the OBD data link connectors, such as shape, pins, location, and identification. For example, to use some sort of color coding to identify the OBD connectors. To standardize fault code handling, dedicating warning indicator lamp to OBD, data stream tracking, freeze frame, CalID, and CDN. Next slide, please. In regards to data stream standardization requirements, our current concept is to include parameters that support PEMS. As an example, torque component parameters. Also to include all comprehensive component monitor input-output components. If you are not familiar with CCMs, comprehensive component monitors are monitors that detect malfunction in engine and emission control system that provides input or output signals that can affect emissions and is not monitored by another OBD monitor. Also, we would like to include calculated and model parameters that support off-road real and some major monitors, such as NOx max emission rate, exhaust mass flow rate, and ammonia storage. In terms of tracking data standardization requirements, our current thinking is to include monitoring frequency, DPF operation, and malfunction history. As an example, regeneration counter and cumulative time malfunction is detected. And also track relative data that is used for off-road real. Next slide, please. But what do we mean? What do we mean by off-road real? The table that we are presenting here is brought from on-road real. And on-road real initiated to characterize the on-road heavy-duty engines' NOx control performance in the real world. However, I have to mention and emphasize that the main elements of real NOx tracking that exist for on-road diesel vehicles are not completely relevant for off-road equipment. But the table is shown here just to show you the concept. And the white portion of this diagram is what is already exists in on-road real. And the green part, this is adopted by in-use compliances, but it has not still been incorporated into real. So let me explain that. So let's say for NOx emission rate that is calculated every second based on the vehicle speed and engine rated power, it is put that parameter NOx emission rate is plugged into bin 1 to bin 14. Also, if the NTE conditions are met, it is plugged into bin 15. If regen is occurring, it is plugged into bin 16. And if the OBD mill is on, it is also plugged into bin 17. As I mentioned, in-use compliances is replacing NTE with 3-bin moving average window to align with the new omnibus regulations. And they are considered 3 bins, bin A for idle, bin B for low load, and bin C for medium and high load engine rates. As I mentioned earlier, the parameters that is used for on-road are not applicable for off-road. CARB staff is working to design a real bin structure that is more suitable and more representative for off-road engines. Next slide, please. In terms of diagnostic requirements, our current concept is performance-based OBD monitoring only for limited major emission control components. As an example, to monitor DPF, monitoring PM sensor-based filtration efficiency, by monitoring EGR low flow, selective catalytic reduction, catalyst, for example, NOx conversion efficiency, reductant dosing systems such as reductant delivery performance, and monitoring NOx sensors, or such as performance of the sensors. In terms of malfunction criteria and monitoring frequency, we appreciate any feedback that you can provide. Next slide, please. We came up with 2 terminologies here, full CCM, comprehensive component monitoring, and partial CCM, which I'm going to explain in the next slide what we mean by partial. So when we say full CCM, for input components, that includes circuit continuity, outer range, and rationality. And for output components, circuit continuity and functionality. But what do we mean by rationality? The rationality that we are referring to here is full rationality, and how it is described in OBD regulation. Rationality fault diagnostic for an input component means verification of the accuracy of the input signal while in the range of normal operation and when compared to all other available information. And we are looking for offset malfunctions and gain errors as an example. And the way that functionality is defined in OBD regulation, functional check for an output component means verification of proper response of the component to a computer command. Our current thinking is to make full CCM applicable to all input-output components related to major monitors, as we described in previous slide, AECDs, and off-road reel. As an example, intake manifold temperature, manifold air pressure, NOx sensors, EGR flow, and engine speed. Next slide, please. When we mention partial CCM, the only difference between partial CCM and full CCM that I explained in the previous slide is for partial CCM, we are referring to simple rationalities such as stuck in range. So for input component, we are thinking about circuit continuity, out of range, and simple rationality. For output component, circuit continuity and functionality. And our current concept is to make partial CCM applicable to all input-output components not covered under full CCM and be related to engine and emission control components. Next slide, please. Our current thinking is also to consider other potential diagnostic requirements, such as standardized fault codes for manufacturer-enhanced diagnostic of emission control components, such as component protection monitors, other performance-based monitors. Also, standardized default action fault code and warning lights. For example, for torque derates, EGR valve disablement, and reductant dosing shutoffs. Next slide, please. In terms of certification requirements, our current concept is to have annual submission of OBD application. Also, a reduced demonstration testing compared to on-road OBD. Currently, OBD uses full useful life engine testing, which is not aligned with tailpipe certification durability requirements. What we are looking in, but for off-road, we are looking into aligning OBD with tailpipe certification durability requirements, which potentially creates a reduced number of procedures and also fewer systems that need to be aged and used for both OBD and tailpipe certification. We are also thinking about allowing one test engine to cover a broader range of engines compared to on-road OBD. We are also seeking feedback on how to group engines. Our current thinking is to have production engine vehicle evaluation testing, such as L1 from on-road heavy-duty OBD regulation. We are also seeking feedback on verification of off-road real data. Next slide, please. In terms of off-road OBD applicability, our current concept is at a minimum to include 56 to 560 kilowatt engines. And for other power rating categories, at a minimum, we believe that in-use compliance program needs standardized connectors and protocols. We are considering other requirements as well. And in terms of phasing schedule and requirements for other power rating categories, we appreciate any feedback that you can provide. Next slide. We got to the end of the OBD presentation. If you have any questions, please feel free to contact my manager, Jason Wong, and myself, Shutdown Dilmagani, and we will be happy to answer any questions you might have. Thank you.
Thank you, Shabnam. I think now we'll look into the Q&A section. Our first question is, from James Addison, and he asks, will the workshop recording become available? The answer is yes. They will be posted on the CARB's YouTube site shortly after, maybe within a week of today. The second question we have is from Ulrich Butke. I'm sorry if I'm mispronouncing it. Oh, sorry, he has the same question, and so it'll be available within the week. James Addison has a question. If the data goes into the NT, regen, or mill bins, is it excluded from the inclusion bins in bins 1 through 14? And I think Paul Hendrick wanted to answer that one.
Yes, good question. Basically, at this point, we would so the current bin structure that you saw was the on-road real bin structure. But the way it works so far for on-road is that only the mill bin that you've got listed there is exclusive to the other bins. So for example, if you have a second's worth of data, which is satisfying the NTE or regen requirements or the conditions, then that data will get put into both the NTE bin and the regen bin and the appropriate bin 1 through 14. So that's how that works. But the mill bin is exclusive. So if the mill is on, then the data is only being stored in the mill bin.
Thank you, Paul. The next question we have is from Deepak Guruswamy. Does NOx sensor performance monitoring include rationality monitoring also? I believe Jason Wong wanted to answer this one.
Yeah, hi. Yeah, for the NOx sensor performance monitors, we're looking for, they're not considered part of the comprehensive components, but like they're considered a major monitor. So we're looking for monitors that would include performance, but not necessarily threshold monitors. So if you're, they would be using, since they would also include rationality monitors too, to make sure that the sensors are appropriately sensing the appropriate values, because they're used for monitoring the SCR. NOx is one of the more important criteria pollutants that Tier 5 is trying to reduce. So yes, they wouldn't include rationality monitors, because a sensor that's inappropriately reading too low would give improper results for the SCR monitor and other components, after treatment components.
Yeah. Hi, this is Mike Regenfuss. I'd like to maybe add a little bit more to what Jason's saying. Our thinking on NOx sensor monitoring is that we'd want to be kind of as comprehensive and as stringent as we can, because the NOx sensor is critical to as an input to the off-road real data calculations. And sort of for the robustness of that off-road real data, we want to make sure the NOx sensors that are providing that kind of like that fundamental level of information are performing as good as they can.
All right. Thank you, Jason and Mike. Our next question comes from Jung Ho Kim. If engine manufacturers do only use DPF delta pressure sensor without a PM sensor to monitor DPF efficiency, would it be accepted by CARB? And I believe Jason wanted to answer the next one.
Yeah, that's a good question. We haven't really decided on like any level of thresholds yet. Right now, we're thinking of having a as far as that threshold, we haven't decided what's an appropriate threshold. So if DPF delta pressure sensor, I don't think we're ruling necessarily that out. If it can detect a certain level of deterioration. So I don't think we've necessarily ruled it out yet, because we're just kind of thinking of we haven't really thought about a particular threshold yet. If we're thinking about a threshold that is would not be detectable by a delta pressure sensor, then yeah, they can't be used. But right now we haven't ruled them out. And I don't know if Mike Regenfuss wants to add anything more on this one.
No, I think I would agree with that, Jason, but I would add that the thinking behind DPF monitoring is somewhat goes in line with the off-road reel proposal, in that the off-road reel data is, at least in the current in-use compliance concept, that the off-road reel data is going to be used as a screening tool or a screening step within the in-use compliance program. And right now, off-road reel doesn't include PM data. So we're thinking of our current thinking or desire is to have as stringent of a PM filter monitor as possible. So if engines are passing the screening criteria for the in-use compliance program, we have a reasonable level of confidence that the engines are both, what maybe I can call compliant with respect to both NOx and PM emissions. So if, depending on the limitations of delta P monitoring in an off-road application, it may or may not suffice sort of at the level of stringency that we'd like to accomplish with that monitor.
Thank you again, Jason and Mike. Our next question comes from Robert Weiss. What standardized connector options are being considered? Keep in mind that J1962 connector is not weatherproof. And I think Jason was going to respond to this one.
Yeah, I'll attempt to answer this question. Yeah, we haven't narrowed down like exactly a particular connector. I think in our discussions with manufacturers, there's this is quite controversial, and so we're open to various connector options. We wanted input from manufacturers on this. Yeah, there's some standardized connectors right now, the 1962 and the 1939 other connectors. We're not necessarily married to any of these particular connectors. They're just like ones that are used now. The 1962 is what's in light duty vehicles. So that's not something that we're like going to necessarily mandate. If it's in an area where weather can impact it, then like the 1962 connector might not work. We might be open to different, like maybe more than one connector type. We haven't closed that option yet. So it's like possible that if some equipment is like totally not impacted by weather, like they're inside the cab, then that might be okay too. So it hasn't been ruled out yet.
Thank you, Jason. Our next question comes from Alguragrajan Karunakaran. What are rough ideas for performance monitoring? At what level of performance is diagnostics supposed to run? And I think Jason Wong was gonna speak on this one also.
Yeah, I'll attempt to answer this one. As far as the threshold or threshold monitors, we haven't honed in on a particular threshold yet, but we do want something more than a comprehensive component diagnostic. Some of you might know how like the on-road threshold monitors work, and they're tied to the emission standard, like a factor or additive factor to them. We can consider something like that, but we haven't really honed on a particular threshold yet. This is just something that we're planning on doing. It would be most likely tied to some kind of factor compared to the standard, but the exact level we haven't honed in on yet. So I don't know if that answers your question or not, but it's going to be more, it's going to be tied to the emission standard, but we haven't decided at what level yet. And so these are all concepts we're thinking of, but we haven't really hashed out the details yet.
And Jason, this is an area where, you know, we'd like to have feedback from the stakeholders. I mean, we understand that the sort of the off-road industry is different than on-road, and there's maybe lots more permutations of the types of equipment the engines can go in, and the duty cycles they can see, and the conditions that they run in. And we can appreciate that you know, creates a significant demand on engineering resources to design and successfully implement a system like that. And so we'd like to have some input from industry on sort of what's a feasible balance between a stringent threshold, but at the same time being able to handle the workload with designing something that works with the products in the field.
Thanks, Mike and Jason. Our next question comes from Jim Roll. Can you explain more details about your requirements on slide 7? Is this a full threshold monitors? I believe Jason wanted to speak on this one.
Yeah, let me okay, so let me look at this question. Threshold monitors, yeah, performance-based monitors. These are considered like the major monitors for on and off-road equipment. And for these particular components, we're looking for something more than the CCM or comprehensive component monitors. So we're planning on having these particular components monitored to some sort of an emission threshold. But we haven't determined what the exact level is. So.
Thanks. I think Steve Berry has a similar question on this. Are these threshold monitors? And do you foresee a difference from how they are implemented relative to the heavy duty on highway engines?
Yeah, we're not going to necessarily seek the exact same thresholds as for on-road vehicles. They run on different duty cycles and so forth, and the standards are quite different. So we haven't really, so there's likely going to be a difference as far as the exact thresholds are. And like I mentioned, we're not necessarily tied to having the exact same thresholds. We might decide to have additive. We might, for something that we had as a multiplicative factor in on-road, or vice versa. So we're right now we're open to any ideas. And so if there's any concerns about like what the threshold should be, please contact us and provide your concerns to us, or describe your concerns to us.
Thank you, Jason. The next question comes from Jonathan Josephs. Was there any thought given to the kilowatt hour minimums? And what is the reasoning behind the kilowatt minimum? And I believe Mike wanted to respond to this.
Yeah, as we kind of teed up on one of the earlier slides about the objectives, a primary objective is to have the OBD concept sort of be in line with what the in-use compliance concept is looking like, and actually to support it and through the real idea. So at least we're trying to create a strong overlap with the power range for the in-use compliance proposal. But then, of course, there, the off-road, the ranges of engines in off-road go beyond what's within the in-use compliance concept. So we're still looking at what we should do for kind of the lower powers and higher powers of engines that are out there.
Thank you, Mike. Our next question comes from Alan Colkimo. Can you explain CVN, or the calibration verification number, further? And I believe Paul was going to respond to this, Paul Hendrick.
Yes, this is Paul Hendrick with the diesel OBD section. So the calibration and verification number, it goes hand in hand with the calibration identification number. Basically, you can think of the CVN as being the output of an algorithm, which is using all of the calibration parameters as inputs. So it produces a value to help us make sure that the calibration on the engine is actually a certified one, that it hasn't been tampered with in a way that is not approved. So yeah, that's what the CBN is.
Thank you, Paul. Our next question comes from Ioma Urium. From the slides, can we assume the off-road reel will only apply to 56 to 560 kilowatt equipments? And I believe Jason wanted to respond to that.
Yeah, sorry, I'm trying to go through like the later questions to see what they are do at the same time. So anyway, yeah, let me read this question. Yeah, right now that's our plan, and as I think the slide, I forget what the slide was that talked about the 56, the applicability. I think it was the second to last slide, Christian.
Let me try and get there.
Yeah, this one. Oops, that one. So right now, that's what we're trying to say here with the first bullet is that we're definitely gonna have off-road reel applied to this particular power rating to support the in-use testing program. So at a minimum, it's everything that was presented here. The concepts will definitely apply to this power rating. For the other power ratings, we're not too sure, and that's why we're seeking feedback here on that last bullet. So that's what we're trying to get input on, is about the other power ratings. But all of the concepts mentioned here, we expect to apply to the 56 to 560 kilowatt power rating.
Thanks, Jason. Our next question comes from Olagarajan Karunakaran. There is a scan tool section, specifications for tracking requirements, which we presume is like monitoring tracking requirement. What are the ideas which are being thought out on tracking requirement for the non-road segment? And Paul Hendrick wanted to reply to that one.
Yeah. So as with everything in this presentation, these are potential concepts. It's a pretty early stage for OBD. So we haven't really defined a concrete proposal for tracking requirements at this point. That having been said, I think we can say with some confidence that the off-road real piece of the tracking picture is a pretty significant one that we're confident we'll be going forward with. There other elements of tracking are the monitor performance, in use monitoring performance frequency, something perhaps akin to what is done on road. That is very much up in the air at this point, and we're certainly open to hearing feedback from everybody as to their thoughts on that.
And Paul, I'd like to add there that at least with respect to DPF monitoring, we want to sort of, we haven't hammered out a concept yet. But as I mentioned earlier, we'd want to consider DPF monitoring results as part of an in-use compliance screening decision. And so it would be important to have good monitoring frequency of the DPF to kind of support that screening data, or to support decisions being made on the screening data, meaning the DPF monitor would have to have completed within a reasonable amount of time relative to when the screening data was collected. So while we don't have a detailed proposal at this point, that's kind of what's guiding our thinking, at least on the monitoring frequency for the DPF monitor.
Thanks, Mike and Jason. It looks like we have another question on monitoring frequency, but broader, from Deepak Goswami. What is the tracking data monitor frequency concept for off-road? Is that yet to be finalized? And I believe Jason wanted to speak on this one.
Yeah, the monitoring frequency concept, that's what we're talking about, in-use monitoring performance frequency or ratios in the on-road regime. And that's basically, we're considering a similar concept to track the monitoring frequency of like select monitors, that how often they run in the real world. But so we're planning on having some kind of monitoring frequency, and but we haven't figured out the scope exactly yet. Most likely they'll apply to like the monitors. They might apply to all monitors, but in the on-road sector, there are certain monitors that are tracked and reported, and then there are certain monitors that just have to meet a certain requirement. We haven't hashed out the details yet, but we do plan on having some kind of monitoring frequency requirement. But with the various duty cycles, environments, and of off-road equipment, that might make it a little bit more difficult to have like a one size fit all for everything, or like, so we're gonna have to really look into this to see what would necessarily work out. And as far as it could be that we're tracking data initially, but not necessarily enforcing them to see what we get. We could start off like that. I don't believe we would necessarily come out with, or we could do something similar to what we did with on-road, set a really low in-use monitoring performance ratio frequency, and not enforce it for like several years, see what the data is, and then come up with before finally enforcing, and then like coming out with a final ratio, required ratio. So that could be a plan or concept that we follow in the off-road sector too.
Thanks, Jason. The next question is from Jung-Hoo Kim. OBD items are decided or still in progress? And will diesel, CSERS / misfire, etc. be added to tier 5? I think Jason is going to speak on this one.
Yeah, my oh, okay. Somehow I can't get my video to start again. Maybe it's okay. Cycling. Oh, okay. Well, anyway, I'll talk. Right now, we don't intend to have CSERS and misfire in to be required right now. CSERS is a very complicated monitor right now, and we don't have any plans right now for either CSERS or misfire. Where the monitors that we listed in this proposal is what we're considering right now. This is something that OEMs want. If it is, and we're be willing to consider adding it. But so right now they're not in the works right now.
Thank you, Jason. Our next question comes from Michael Reed. Is there some form of IUMPR being considered, as it appears traditional for the OBD2 or heavy duty OBD threshold monitors do not yet appear to be in scope of what CARB Tier 5 proposal? And I think Mike Regenfus wanted to speak on this.
Yeah, I think we've touched on this one in a couple of different questions already, and we are looking at some form of IUMPR. Yeah, I think I touched upon sort of what we're thinking relative to DPF monitoring, that we want that monitor to be relatively stringent, both with respect to an emission threshold and with monitoring frequency. As far as the other monitors go, I think on that slide where we mentioned performance monitors, we are looking at seeking feedback from industry in terms of setting malfunction criteria and monitoring frequency requirements, which would sort of include a discussion of IUMPR. And maybe for the group that some people participating today might not understand IUMPR, that's a term that we have in our on-road regulations, and it means in-use monitoring performance ratio. And it's basically just onboard algorithms that track how frequently monitors are making decisions relative to kind of you might call it an arbitrary metric of some amount of vehicle or engine operation. And so it just basically gives you a metric of monitoring frequency.
Christian, can you please show the slide 7, since we're talking about the monitors?
Sorry, let me change over to that.
Thank you.
Thank you. Here. I think our next question comes from Agurajan Arunkaran. DPF monitoring is mentioned, so for example, with a PM sensor. Are there limits which are in discussion? I think Jason was going to speak on this.
Yeah, I think kind of talked a little bit about this earlier. We're not necessarily we haven't decided on a threshold for this particular component, DPF or diesel particulate filter, and so we haven't. Depending upon what threshold we decide on, if it's more stringent, then a PM sensor would probably have to be used. If we choose something that's a threshold that's less stringent, it's possible that a DPF sensor could be used. So it's really dependent upon the limits. In the on-road sector, manufacturer, when the thresholds were the malfunction thresholds for PM were looser, many manufacturers could still use the delta pressure sensor, but they had difficulties in monitoring a certain part of the in-use monitoring of not the in-use monitoring of the monitoring requirements when we were looking for cracks in the filter, and the delta pressure sensors were blind to finding some of these cracks and melting of the DPF. If we apply that similar type of requirement, then it might make the PM sensor necessary. But we haven't really decided on what requirements we're gonna seek here. If we want to have something similar as on-road or not. So we haven't ruled it out yet. So I can't really say if a PM sensor would be required. But again, like on this slide here, we're seeking feedback.
Thanks, Jason. The next question for you comes from George Lynn. For the less than 56 kilowatts and greater than 560 kilowatts, would these not be required to have standardized connectors and protocols?
I don't think we've necessarily stated that. I think we would. I think at a minimum, for all of the different power ratings, we would want to seek standardized connectors and protocols. So that is something I believe we're considering for those. As far as like the scope of like the monitoring requirements, we haven't. We're seeking input. I think you go to slide 12, I believe, Christian.
Sure.
Again, it's we're seeking feedback on phase-in schedule and requirements for the other power ratings. But I think standardized connectors and communication protocols will be a given for the entire off-road tier 5 category.
Thanks, Jason. The next question for you is from George Lynn again, and he asks, is there any comments on post-production testing requirements?
Yeah, I think I forget what the slides are. It might be slide 5 or 6 that it talked about the L1. Let's see, I don't have potential standardized. Can you go back maybe slide 4? No, okay, go to slide 6.
Slide 11 has the L1.
Oh, okay, slide 11.
Jenna.
Thank you, Jenna. Okay, so we're seeking, well, it doesn't say we're seeking feedback, but right now our idea for post-production testing is just to verify the communication aspect that's like stated in the current on-road regulations, or L1, section L1 of the on-road heavy-duty OD regulation. So some of the manufacturers that are familiar with the on-road requirements know that there's like 4 different verification test requirements for the on-road sector. And so L1 is like one of the tests categories, and that like tests that communication is meeting can communicate with a scan tool because it's using the correct standardized protocols, and there's like a software test that's developed by industry and a working group that that verifies that the system is working correctly. So it makes you run through, have the software, and it makes you run through a couple of different processes and putting malfunctions in and so forth. And it checks to make sure that the various communication requirements are being met. So that is the extent of what we're considering right now. We haven't necessarily ruled out like the other 3 tests, but right now this is what we're considering now. The other tests would be a little bit more resource intensive, and we're still weighing the benefits and the costs of having something like that also implemented. So that's why we've honed in on just L1, or the communication protocol testing requirement.
Thanks, Jason. The next question comes from Ioma Uriam. What is it meant by OBD off-road real verification? Are we talking in a test cycle environment or some kind of in-use verification system? I think Paul Heinrich wanted to speak on this one.
Yeah, I'm actually not entirely sure about the nature of the question exactly. So Ioma, if what I say next doesn't hit the mark, then please feel free to clarify in a subsequent question. At this point, it's conceivable that we'll have a similar NOx mass accuracy type verification as we do in the on-road context, where we compare what the engine control module is indicating as being its NOx mass calculations versus what the lab is what's being measured in the lab over the same test cycle. That's certainly on the table. But beyond that, I'm not sure what else might sort of be related to some kind of verification step.
Yeah,
Okay.
Paul, maybe I can jump in and add a little bit here. I mean, we did have this bullet listed as shown on the screen right now as production engine vehicle evaluation testing. And the thinking is as we've indicated elsewhere in the slides in the discussion, that the off-road real data is going to be, it's going to be the initial step, screening step in the in-use compliance program. So the validity of that data is really important. And so we think that there's value in having some form of production evaluation of that data to make sure the data is correct. So then later on in the life of the engines, when that data is being used as part of the in-use compliance program, that we can rely on that data. So that's sort of the need we're trying to address. But we don't have sort of a detailed more details to provide on the concept at this point. And that's why we're seeking feedback from the stakeholders on that topic.
Thank you, Jason and Mike. Our next question comes from Robert Hasselbrook. I'm dealing now with some mill problems with light-duty vehicles on a Chevy with mill alerts that need to be clearing, but the mechanics cannot find any problem with the engine and thinks there's a wiring problem through the code. I have a family member with a light-duty vehicle Ford that is likewise having problems, and Ford can offer no answers or solution. Both are out of warranty, though not high mileage, and lots of life left on them. If this problem happens in the medium to heavy duty vehicles in California, how will they stay as a useful vehicle in California? I think Mike wanted to speak on this.
Yeah. Well, Robert, thanks for the question. I guess this is a question not so much related to the off-road discussion we're having today, but certainly related to other OBD requirements that we have in place, but particularly as they apply to our smog check program and our for light duty or medium duty trucks and our heavy duty program or heavy duty inspection and maintenance program for heavy duty trucks. You noted both the vehicles are out of warranty, so that is a situation where the owner of the vehicle is responsible for making those repairs, and those repairs do have to be done ultimately to pass an inspection, and in the case of the smog check program to be able to get your registration renewed, and for the heavy duty program, as those vehicles are inspected in the future, you will have to have passing results there as well. Sounds like on one of the problems here, maybe some of the mechanics or technicians have an idea that the problem appears to be a wiring problem, and certainly wiring problems can result in the check engine light or mill on. Sometimes wiring problems are, they are a real malfunction, but they're within the wiring harness, so they admittedly can be a challenge to troubleshoot and repair. I think a potential option is that maybe you seek service outside the dealer network and work with independent technicians. There's certainly lots of capable independent technicians out there. I believe in the smog check program, if there are challenges in making a vehicle repair, there might actually be some opportunities to sort of get a temporary reprieve, if you will, on passing the inspection. Which means you can still get your vehicle registered and get more time, sort of buy more time, if you will, to get to the root cause of the problem and make an effective repair. I'm not quite sure exactly how that works within the heavy duty program, and perhaps there's someone else here on the panel that might be able to address that as a follow-up. So Christian, maybe we can move on to the next question then.
Okay. Sure, thank you, Mike. The next question comes from Jung-Hoo Kim. On slides 5 and 7, does the monitoring frequency mean IU MPR?
Yeah, I think this question's been answered previously. Yeah, monitoring frequency means in-use monitoring performance ratio. So I think we kind of talked about this previously between me and Mike, that it's a monitoring frequency in comparison to some kind of set operation requirement. So just as a base. Mm-hmm. So yes, that is correct.
Thank you. Next question comes from Ioma Emuram. Did not see any direct reference to NCD or PCD requirements in the slides. Unlike global regions on these requirements, can we expect the same OBD monitoring requirements to be applied to the NCD, PCD requirements if these are adopted by CARB to further inducement for Tier 5?
Hi, this is Yongyu from OBD branch, and I would like to address these questions. And the first thing is that here the NDC and the PCD is just the NOx control device and the particular matter PM control device. As you see in our slides, actually we set the quite a difference as the NCD or PCD requirements on the, for instance, the China regulation for the off-roads. Because the first thing you will see that on the slide, we do put certain kind of the threat monitor for the certain kind of components. So theirs will be definitely different to the global the regulation, because this just in general it's just a function check and no threshold will be linked to this kind of the monitors. So that's pretty much like the short answer to this one is that yes, we're monitored requirement is quite different as they propose there. And for the inducement part, I'm not very much familiar with that. Maybe the general section people can talk about that, and maybe Jason and Mike, if you want to add more to my answer to this question.
Yeah, so I'm going to read that part of the question. Can we expect? Let's see, can we expect the same OBD monitoring requirements as applied to the NCD, PCD requirements of those adopted? Yes. So right now we're looking at our inducement requirements for off-road, and we plan to have a work group meeting on that at some point, probably next year or so. At the minimum, we currently have inducement requirements that manufacturers are held to for SCR, and so we'll likely definitely be codifying what are currently required. In terms of the NCD and PCD, that's something that we've asked manufacturers for their opinion on, and we'd love to get your feedback or continue to get your feedback on that. Next question.
Yeah, thank you, Young, and thank you, Jenna. The next question comes from David Pick. Most off-road engines and equipment OEMs have no OBD experience, exceptionally possibly for one engine OEM. This would require significant staffing to these companies with limited staffing ability. The heavy-duty OBD allowed a lengthy implementation timing between 4 to 6 years for the EMD, then 3 years for limited heavy-duty OBD before the full OBD program in 2013. What is expected for implementation timing? Would CARB consider a similar phase-in with the off-road EMD than limited on-road OBD or off-road OBD? I think Jason wanted to speak on this one.
Yeah, thanks for the question, David. I think you've written some valid concerns, but I think we're open to having some kind of reduced or extended implementation. But if you're right now, you're talking about some of the concept you mentioned are currently in the on-road heavy-duty OBD regulations, and we're most likely won't have like a true just EMD phase. I think if you recall with the implementation of heavy-duty OBD, we required like a full-on OBD at least on one engine family. I think a concept like that would probably be okay, but to have like an extended just EMD before that with no off-road OBD, I'm not too sure that would be appropriate here. But perhaps something like a limited phase-in of off-road OBD to reduce the resource requirements. And then like I have like a full-on implementation several years down the road. To kind of, and we could consider like a lot of other criteria like the size and so forth of the manufacturer, but and other like grouping type features. But I think our plan right now is to have like an off-road OBD at least being required like from the beginning of the implementation, but maybe limited. And then like some of the other ones some of the other engine families can be provide whatever OBD that they currently have, and it could be dependent upon size. We're open to. We haven't really thought about like the exact scope yet, but implementation, something similar to the on-road sector, we'll consider. But but most likely not like a full-on EMD for several years before implementation. The EMD regulation was something separate, and it was like a totally different regulation from the heavy duty OBD requirement. So we're kind of think about this as kind of like similar to the start of the heavy duty OBD regulation, instead of including the EMD part, like that's a separate regulation. Hope that answers your question.
Yeah, Jason, maybe I can add a comment here as well. Thanks for that answer. I do agree with it. And I just like to point out that, you know, elsewhere in the presentation, we've sort of emphasized how we want to standardize off-road OBD as a tool to support both the manufacturer run in-use compliance program and a CARB run in-use compliance program. So with that in mind, I think we would, as we consider phase-in options, and that maybe as manufacturers come and give us their more detailed feedback, we'd sort of like to kind of front load any phase-in discussions with early standardization, because that is a major part of the proposal, and it's a major part of some of the other overall Tier 5 concepts.
Yeah, I think I agree with that, Mike, too. And David is probably aware that, like in the heavy duty OBD implementation, when we did require the EMD part, or limited OBD, the non-full OBD engine families, they were required to at least meet the communication protocol requirement. So I think so that would match up with what Mike just mentioned.
Thank you, Mike.
One thing
Chief.
I wanted to mention was also we're open to alternative concepts, as we keep saying throughout the slides and throughout the day. And so we have received alternative concepts on many different elements of Tier 5, including OBD. So we just want to encourage stakeholders to please continue to submit those, including on timing and and content, the concept.
Thank you, everyone. Our next question comes from Euro Kotemaki. The in-use tailpipe NOx with Tier 5 level after treatment will be something around 1 to 3 ppm when SCR operating temperature is reached. Is there any proposals presented yet on how to measure such low concentrations to allow reliable NOx reduction monitoring for OBD? Mike was going to speak on this one.
Yeah, we don't have a detailed proposal at this point. This is an area where we were seeking feedback. We do recognize and acknowledge that, yeah, tailpipe levels will be around, those single digit concentrations. And so that is something that we have to take into account when we propose and ultimately adopt malfunction thresholds. I think the way the question's written, it's specifically trying to get at what an emission threshold might be for some of the performance monitors. On a separate note, we understand that these low concentrations sort of also have implications in terms of the off-road real data that's generated, and we're looking at doing some studies into that as well to try to find, I guess, opportunities, methods to work with the actual low tailpipe concentrations and limitations of current production sensors, and to try to develop methods to make that off-road real data the best it can be, given the situation that we're working with.
Thanks, Mike. The next question comes from Michael Reed. The agency may want to consider language for several areas of the off-road OBD requirements for either constant speed only and variable speed engines. Some areas of future regulation may be more straightforward than others. For example, entry conditions, BPU and WPA separation limits, etc. I think Mike wanted to speak on this topic.
Yeah. So maybe as for starters, BPU and WPA is best performing unacceptable and worst performing acceptable, and those are terms that are used in the context of identifying passing and malfunctioning parts in the field, and trying to create a diagnostic that it makes really sound, robust decisions about whether a component or system is passing or failing. So Michael, thanks for the comment. I think it is a good one, and we'd certainly like to hear more on this topic, that if there are sort of unique challenges with one type of engine or application versus another one, we'd like to better understand that, and certainly factor that into our thinking, as we think about thresholds and monitoring frequency, and maybe considering the previous question, even like implementation schedules. So let's have more detailed discussions along these lines.
All right, thank you. The next question is from Scott Gordon. What is the model year timing staff is considering? And he asks, is it 28 model year? Jason, did you want to respond to this?
Yeah, I think we're trying to match up with the Tier 5 folks, at least like the beginning of the implementation. We might have like a different implementation phase in, but I believe that they're planning on going to the board in 2025-ish, and implementation, I believe that and Jenna, you can correct me if I'm wrong, but in 2028 to 2009 timeframe. So we plan that. Yeah. Okay. Thank you. So we plan to match their implementation timing. But again, our at least their start date. But we might have some different phase-ins for reduced OBD requirements, possibly for some of the engine families, as I mentioned previously.
All right, thank you, Jason. Next question comes from Robert Weiss. Will there be special denominators for DPF and SCR infrequent monitoring?
Okay. Yeah, Robert, I'm assuming you're talking about some of the monitors that don't run too frequently, like the ones that require a regeneration, or as far as those special denominators that are in the on-road sector, I think we can consider something similar, and it would seem to make sense if a monitor doesn't run frequently, that we have a special denominator for them. Other ways of doing it would be just to have the same denominator but have a far reduced ratio. So we can do it either way. We're not necessarily tied to the exact methodology that we do in on-road. So we can do it like a different way, keep things simple and just have the same denominators that the monitoring frequency is judged on, but have a lower ratio. So, but we haven't really gotten into like these fine details yet. We're just trying to right now we're more in the big picture part and just trying to explain what we're thinking of right now. So we haven't gone too far down the rabbit hole yet to really think about these details yet. But you're welcome to provide comments on this.
Thank you, Jason. The next question for you from Robert Weiss again is regarding the IU-MPR track and report with the J1979-2, there will be by DTC IU-MPR track and reporting.
Okay, it's at yeah, that's looks like it's just a comment. I don't see a question there.
Okay.
I think he's talking about this new requirement that we had put in our recent rulemaking that requires like these DTC based like individual monitor UMPR tracking. So I don't see a question here. Looks like he's just making a comment.
Okay.
Do you see a question?
No. I mean, he says it's a
Maybe
comment
the question is, will there be by DTC IU-MPR track and reporting?
Yeah, I don't think we've necessarily gone down that road yet. I mean, in previous to this particular communication protocol requirement, it was like UMPRs were tracked according to a group with the worst performing UMPR being reported. The only difference with this J1979-2 requirement is now you get the individual UMPR requirements, not just the lowest one. So it seems like I mean that's the difference. We haven't gone into these details yet. We haven't necessarily decided on a protocol. It might be like we might like allow more than one protocol is a possibility, but whatever protocol is allowed or is decided for off-road OBD, if like J1979-2 is one of the options, it most likely would include this, but doesn't necessarily have to. We could make a J1979-3, for example, and just make it or just make it more like the classical J1979, which is just called J1979. But we haven't really decided on what to do exactly yet regarding the communication protocol. But is there like a concern about this particular requirement, this individual DTC? If there is, please let us know. But we haven't really decided on protocols yet, and perhaps like manufacturers should provide input on communication protocols that they think should be allowed or preferred. So that's my comment on this. I don't know if Mike, you have anything more to add on this?
No, I don't, Jason, thanks.
Thank you. The next question comes from Alagurajan Arunankaran. Reduced demo is something appreciated. Ruling out DDE engine requirements, nevertheless, which are cycles which are considered for a demonstration? At this point in time, the NRTC, the SET, what threshold parts, full parts, it would be helpful to discuss what the concept and ideas are. I think Jason wanted to talk on this.
Yeah, I'll start out trying to answer this. I think that we had a slide on, unfortunately, I don't have a copy of the latest slide on the demonstration about the reduced demonstration. I think earlier on, keep going up, Christian. Reduced demonstration. Okay, let's see. Keep going down now. I think it was well, we mentioned full useful life that we're trying to.
Yeah,
okay,
slide 11.
Okay, slide 11 is where we mentioned that the reduced demonstration testing relative to on-road OBD. So that the first sub bullet mentions that we're thinking of different from current on-road OBD requirements for aging the engine and the system for demonstration testing. We're going to attempt to, our goal is to align with the tailpipe certification folks with their durability requirements. So whatever they come up with or allow, we're going to align with them. So that would like simplify, hopefully, like the testing, and maybe perhaps one system could be used if possible, but it may still require more than one for logistics and other reasons. And the second sub bullet talks about like how we plan to allow a broader range of one test engine to cover a broader range of engines. Sometimes we call that grouping in the on-road sector. So how to group these particular engines, we're seeking feedback. As far as the question mentioned about the test cycles, I don't think we've gone that far into talking about the test cycles. So right now, we're thinking of the concepts and we haven't gotten into the details yet. So if there's some preferred test cycles, you can reach out to us and let us know thoughts on what the test cycle should be. So I don't know, Mike, if you have any ideas for test cycles as far as
maybe Christian can scroll back to slide 7. We in essence touch upon this. You know, test cycles really are relative to malfunction criteria, and in some ways, malfunction criteria and monitoring frequency go hand in hand. I think as a guiding principle here, we're trying to strike a balance between, as we do with our on-road programs, between stringent emission thresholds as well as frequent monitoring in the field, while achieving monitors that are making robust decisions. And what we mean by robust is the monitor properly decides that a good part is passing the diagnostic, and a part that has, you know, failing performance is truly identified as a failure by the diagnostic. You know, we recognize that for the spectrum of off-road engines and applications. Making these diagnostics work in the real world is in many ways it's very much the same as the on-road challenge, but in many ways it's different and unique and perhaps more challenging as well. So this is an area where we're seeking feedback to try to strike that balance. I think, you know, it's generally for all of our on-road programs, we have emission threshold criteria that are set as a function of a test cycle. And I guess I could say that that's still our current thinking here. But if the challenges are too great there, then perhaps we'd be open to suggestions on other metrics. You know, for example, perhaps some way of you know, some simple NOx conversion efficiency threshold for SCR versus a tailpipe based method that's a function of the test cycle. So I guess we really would like to hear from the stakeholders.
Okay, thank you. The next question comes from Michael Reed. The heavy-duty OBD phased-in is scheduled, was partially written into the regulation to accommodate various class applications, etc. With the implementation of the off-road OBD, an even greater range of applications in addition to power categories, would the agency share current thoughts on methods as well as maximum number of model years for a manufacturer to achieve full off-road OBD on all engine families? Jason?
Yeah, I think this question has kind of come up previously, but I think I'll try to answer it again. We're at a minimum, I think we're gonna want implementation to start at least on a limited number of engine families starting in the beginning of Tier 5. And the idea is to at least have one that meets everything. For the other ones, other engine families, our thoughts are that we need to support our in-use compliance testing program. So we need the standardized connectors, standardized communication protocol, and the off-road real tracking. So at a minimum, that reduced OBD requirement we would probably want to begin with. So we haven't actually come up with the exact time frame of everything, and I think your question seeks the maximum number of model years. We haven't given much thought to that number yet, and we haven't really thought about how we're going to structure all of the different range of applications and categories, and this whole off-road sector has different economies of scale. There's some that I think have very low numbers because the price of very low numbers of production because of the price of the equipment is so expensive. So yeah, we're open to discussions on this, but our I mentioned the goals we're trying to achieve. Whether we can achieve all those in the time frame we want, it's kind of unknown, but that's what we would like to do. Is at least support our in-use compliance program with standardized requirements and off-road real testing to begin with, and ideally for all categories, and then have the monitoring requirements come in the full-on OBD would be maybe on a limited number of engine families, and then phased in over time. But we haven't come up with the exact implementation or phasing structure yet.
Thank you, Jason. The next question comes from Pierre-Marie Hussoff. Thanks for a presentation in the Q&A. In terms of OBD system certification documentation, are expectations for Tier 5 to be similar to the heavy-duty OBD system certification, A through S documents? For example, the checklist, summary tables, AECD, etc. Jason wanted to
Yeah.
speak on this?
I think that's a good starting point is to have the same certification or similar certification documentation requirements as for the light duty or for the heavy duty on-road OBD requirements, which are in fact similar to the light duty. But anyway, there might be some aspects of the A to S documents that don't really apply because of yeah, I don't know offhand, but there might be some that don't apply. But that might be a good starting point that we try to adopt.
Christian, can you read the
Yes.
question by Robert Weiss at 929? It's an FYI, but we should still read those questions.
Sure. So from Robert Weiss, an FYI, the draft 1699-5 standard for the J1979-2 and test software available on SAE Works and the AAI website. Thank you, Robert. The next question comes from Alaguranjan Krakaran. Regarding the possible EGR flow monitoring requirement, has been taken into consideration for the different EGR layout / controller that non-road applications usually have compared to the on-road applications. For example, a missing airflow sensor. I think Jason wanted to comment on this.
Hold on for a second, Christian. I'm trying to find the question. I was scrolling down. Let's see. What time was the question?
9:35.
Okay, I found it. Possible has been. Oh, no, we haven't actually looked into the emission control layouts of the different off-road like equipment yet. If there are some concerns, definitely let us know. I'm not too sure what the difference in the EGR layout is that would make EGR low flow monitoring difficult. You mentioned here an example, missing air flow sensor. In the on-road sector, there's people can do low flow monitoring with it's just missing airflow like the intake. I know like maybe I need to ask Paul Hendricks to help up on this question since he does a lot of the on-road diesel certification. Paul, can you like maybe help me out with this question here? Like, are there any on-road heavy duty manufacturers that monitor without an airflow sensor for EGR low flow?
Yeah. You don't need a MAF sensor for designing a EGR low flow diagnostic. So yeah, there are ways. Mm-hmm.
Okay, thank you, Paul.
Mm-hmm.
Thank you, Paul and Jason. The next question comes from David Pike. Is CARB considering off-road OBD deficiencies? Heavy-duty OBD implemented with heavy-duty OBD deficiencies up to $500 per engine. $500 per engine on a 30 to 50K engine is not on a large impact. However, the $500 per engine on a $3,000 to $5,000 engine is a significant cost impact.
Yeah, thanks for the question, David. I think we haven't really talked about deficiencies yet, but there's, as far as fines, normally in the start of a new requirement, if with deficiencies, and if we decide to have like fines and a fine amount, we've given like free deficiencies over time. If you recall, for the heavy duty OBD implementation, it started off with free deficiencies for several years before we started to charge, and it didn't start up at $500 per engine. For the heavy duty sector, we recently, I think in 2018, we had increased the deficiency fines of $500 per engine because we found that there was a production vehicle requirement called manufacturer self-testing that it seemed to us, it appeared that well, let me back up a little bit. The deficiencies values were, or charges were, a lot smaller. At that time, it was like $25 to $50 per deficiency, depending upon what was deficient. And so some manufacturers were kind of gaming the system, we felt like, in having multiple deficiencies, especially ones that and not meeting the threshold. And we felt like they were trying to game the system a little bit by like just having a large amount of deficiencies, because and when it came to like MST, manufacturer self-testing, they wouldn't be liable for those threshold exceedances and so forth. So we chose a higher deficiency amount to what you call it, minimize that or close that loophole. I don't think, if we're not going to have MST testing requirements for off-road, we're probably not going to implement a similar fine structure. It would probably be more in line with the previous fine structure if for deficiencies. So those are my thoughts on it. I don't know if Mike Regenfuss has any other input on this.
Maybe a little bit. I would just like to say that we don't want manufacturers to sort of use the deficiency provisions as kind of a business planning provision where they just opt to take a deficiency and pay fines instead of designing a compliant system. The concept of the deficiency provisions was really that a manufacturer has made their, a good faith effort to truly comply in full, and then in that process, they've kind of hit some pitfalls and sort of needed a relief valve to move forward with certification. So I think, I agree with all of Jason's comments. I don't anticipate we'd be having a fine structure that looks like the 24 model year and subsequent structure for on-road, but at the same time, we just want to make sure that the deficiency provisions really are viewed as sort of a relief and not just another sort of business tool to get certified.
Okay, thank you, Mike and Jason. The next question comes from Pierre-Marie Hussoff. Are specific requirements for hybrid electric system monitoring to be expected, similar to the ones under the heavy-duty OBD comprehensive components monitoring requirements? I believe Paul Hendrick would like to speak on this.
Yes, a very good question. We certainly would want to have monitoring requirements for hybrids on the table. It's something that we do care about, monitors that specifically look at the battery pack or the energy storage system, thermal management systems. It hasn't been really developed at this point, but yes, it certainly would be on the radar screen.
Thank you, Paul. David Pike has another question. The off-road real telematics and off-road OBD, many off-road engines and equipment manufacturers with significant experience in staffing will experience staffing since they also have telematics on their equipment. For example, Deere, Caterpillar, CNH, Class, AGCO, and Komatsu. Telematics are generally not used on smaller engines, less than 130 kilowatts. In addition, off-road OBD staffing, this will also require significant staffing and resources for the off-road real telematics. Is CARB considering any exemption or exclusion for limited engine/equipment sales in California versus the engine equipment manufacturer size? For example, sales of grape harvesters into California may be in the tens of years, and being a grape harvester, I think CARB would know where to locate them. I think Jenna wanted to speak on this question.
Yeah, I'll take this one. So right now we are not considering any exemptions or exclusions for limited engine or equipment sales into California. But we are taking any concepts that you want to, or comments that you have, feedback on this. The other thing is, we've talked about phase-in schedules, and so that can help alleviate some of your concerns. I think Mike and his team have mentioned, some sort of OBD phase-in, which would include the off-road reel. And then in terms of, for the manufacturer run testing program, we are doing some thinkings on when that would be phased in. So as an example, we could accept data, as Mike's already mentioned, and look at the data, and then and start looking at enforcement of the program in several years. So those are the types of concepts that that staff is thinking about right now.
Thank you, Jenna. The next question comes from Yoma Uriam. Partial CCM calls out for simple rationality, while full CCM just states rationality requirements. Can you clearly provide a few examples of the different enhanced rationality diagnostics expected in the full CCM requirements relative to the partial CCM? I think Jason wanted to speak on this.
Yeah. Thanks for the question, Yoma. I hope I said your name correctly. As far as the slide that the simple rationality, I think we had called out an example as like for example, a stuck check. So that we kind of consider to be like one of the more easy diagnostics to rationality diagnostics to implement and design. For the full CCM, it's just states rationality requirements, and it would be similar to what at least our thoughts are. It should be similar to what is required in heavy duty on road, and it's rationality monitors to the extent feasible using existing sensors. So to help to conduct the rationality diagnostics, some examples would be like an offset or error type monitor, or one that looks for like a gain error malfunction of the sensor. So those are like two examples that that would be part of what we consider full rationality diagnostics, and it would have to be double-sided, like both sides, like not just like a low gain or low offset, but like a high gain and high offset too. Hope that answers your question.
Thank you. Thanks, Jason. The next question comes from Christopher Millinger. It says on slide 4 that the J1939 and J1979-2 will be proposed as communication protocols. Will there be any options for what communication standards to follow? For instance, will it be acceptable using the ISO 27145, relying on a UDS protocol according to ISO 14229?
Yeah, I think I have this question too. In the slide here, we mentioned in the parenthetical J1939 and J1979-2. I think we meant to have that as being an example and possibly a starting point, but we haven't ruled out other protocols yet. We're weighing like if we should limit it to like one protocol or have multiple protocols, and so we haven't ruled out any other protocols. I'm not familiar with these designations. Is this the Ethernet protocol that is described here? I'm not too sure, but anyway, we haven't ruled out any protocols yet. But if there's concerns about like the protocols that we have listed here, and you want like additional options, I know in the on-road sector there's been a push to have like Ethernet protocols allowed, and so I wouldn't be surprised if that would be also be requested for the off-road sector.
Thanks, Jason. The next question here is from Robert Weiss. Has EPA begun any Tier 5 discussions or NPRM in conjunction with CARB's effort? I think Jenna was going to speak on this.
All right. Yeah, right now they do not have an NPRM out, but they are participating in Tier 5 meetings with us. We have separate meetings with EPA, and they're also involved in our off-road low NOx demonstration program with Southwest Research, and then they also took the tours with us that we took in September. So they're engaged, and we're hoping that they'll be able to harmonize with us in our time frame, and we continue to look forward to working with them. So Christian, I think that I was told that I think Steve Barry has his hand up, and I can't see who has their hand up. Maybe you can, but maybe we can take some hands right now.
Okay, Steve, I'm going to ask you to unmute and you can make your comments and questions.
Great. Thank you, Christian. Can you hear me?
Yeah, we can hear you.
Good, thanks. Thanks very much to the OBD team for putting together the materials here today and sharing your thoughts, and we certainly look forward to further engagement. Appreciate all the open questions here this morning. I'm sure that you've heard from the OEM visits that the diversity of non-road product requires that it be treated very differently from the heavy duty on highway side. I'm sure you've heard that message multiple times. The number of different pieces of equipment and applications, the very different duty cycles and varied duty cycles that you see in non-road will present challenges to comply, and more specifically to comply with OBD requirements. And I really think that's reflected in some of your work and thinking that we we heard today. So much appreciated in that respect. The inability to identify perhaps drive cycles. And by the way, I'm sorry, I don't think I have a question here. Just important to raise some points. The challenge to identify a drive cycle for enable conditions for some monitors that are used or that will be witnessed across the broad range of applications will be extremely challenging. And there's been a good bit of discussion about IUMPR and the challenge to meet highway-like IUMPR levels. So I think the idea of a pilot phase for IUMPR could be really interesting and very necessary. With respect to, I wouldn't interpret any questions around misfire today as a request to introduce misfire. In fact, that's kind of one of the areas where it's an extremely challenging monitor to meet already today with highway products. And that's in systems that are fairly similar from one truck to the next, a driveline connection to an interface, a rubber interface with the road. And since this monitor looks at system dynamics, you have a very different situation on the non-road side with mechanically coupled elements that will introduce all kinds of different torsional behaviors and such, and make misfire monitoring a real challenge in the non-road space. And maybe that's exactly why you've held it from consideration in this earliest phase. But I think that's important to understand. EMA has established an OBD committee strictly for non-road. I know that you've interfaced a lot with our heavy duty on highway committee. We've created a new committee dedicated to the non-road OBD requirements. So look forward to working with you there. And I want to just say one more thing about phase-in. Of course, all these OBD requirements are quite new. We're starting at ground zero in introduction of highway experience, highway requirements, highway challenges in this new OBD committee for the non-road folks. And we intend to bring some phase-in concepts to you for the various OBD requirements. And while I understand Jason was describing that maybe the full requirements would be required for one engine family at the first Tier 5 introduction, I just want to express that could represent, truly an insurmountable challenge. Our understanding is that the rule Tier 5 regulation is anticipated to be taken to the board, let's say in our understanding it's 2025. Maybe by the time it's final, what with comments and issues to be worked out, and it could be 2026 before it's finalized. And a first implementation, we understand, of 2029. That's barely 2.5, maybe years of lead time. And for significant NOx reductions, significant PM reductions, the kinds of reductions that are even more challenging to achieve for non-road because of all the packaging issues across a wide multitude of equipment types and equipment vendors that the engine manufacturers have to plan for and do good solid engineering work with. And for those manufacturers to finalize the calibrations in that short time frame to a level appropriate to also do all of the final OBD tuning, even on one engine family, and all the communication protocol, software work and verification, the full gamut of OBD requirements, along with the emissions reductions in an industrialized product in a 2.5-year time frame, just seems like it hits the impossible chord from my first view in this first discussion. But we'll take it back. We'll consider other options for phase in and look forward to having those discussions with in the future.
Thanks, Steve.
Thanks for giving me the floor a moment. Maybe I'll think of a question here real quick, just so I can be honest that I had a question. No, go ahead. Thank you.
That's okay.
We have another raised hand from Robert Weiss. We're going to ask Robert to unmute here.
Hi, thank you. This is Rob Weiss from Mahindra Automotive North America. There was, just to chime in a little bit of clarification. There was some question about the communication protocols, if like UDS and 27145 would be allowed. Just to be clear, J1979-2 is basically a superset. It is UDS. It is basically takes a lot of what's already in 27145, including the fault code rules. So I just wanted to point that out, and I chair the SAE Vehicle EE System Diagnostic Standards Committee. So a lot of these standards like 1979-2, 1979-3 is actually being balloted now, and it's going to be electric vehicle specific. So that's just another point. So, but thank you for the clarification that there might be other protocols allowed. It is a big step up. You know, I noticed the on-road sector and light duty is going over to UDS 1979-2 as of 2026, 2027. So my thought was, well, it would be, you know, a good harmonizing to have a 2029, 2030 type phase in to be, you know, to go also with, you know, with 79-2 versus, you know, 1979 will become kind of the classic version of 1979 will become kind of a stabilized protocol going forward on the on-road side. So I just wanted to point that out as far as UDS goes.
Thank you, Robert. If I'm not mistaken, I think we have all of the questions answered.
All right. I think Christian, why don't we ask for another round of questions? Do people have any more? If not, we'll wait a second to see if anybody types anything in or raises their hand. And then if not, I think we should take a break at this point. We're about an hour ahead of schedule, so we can take, you know, a 15-minute or half an hour break, whatever people think is best, and then just dive on into the average banking and trading.
I'm not seeing any new questions come in. Maybe my suggestion, maybe should we take around a 15-minute break and re-adjourn at 10:50?
Yep, that sounds great. If you can put a note on the screen that just says taking a break, be back at 10:50, so people know, and we'll start up with ABT.
There's still one hand up. Did that Robert Weiss, did your
He
comment
just-
get addressed?
Yes.
He just
Okay.
spoke.
Okay.
All right, perfect. Then
Okay.
let's take a break for 15 minutes and we'll come on back. So keep your screen on. Thanks, everybody.
Thank you, everyone.
So 10:51.
Yep.
Sure.
All right, welcome back. It's 10:51.
That's right.
We're a prompt group. Go ahead, Christian.
Okay, so our next agenda item here is on the topic of average banking and trading, or ABT concepts, led by Jeff Lowry.
Thanks, Christian. Let me pull that presentation up. Give me 1 second.
Sure.
Actually, Christian, it says I'm disabled from sharing. If it's an issue
Let
to
me
give
see.
me the privileges, you can just pull up the presentation and flip
Let me
slides.
let me see if I can give you the privileges. I don't think I can. I think I'm going to go and share the ABT presentation, if that's okay with you, Jeff.
That's fine. Thank you, Christian.
One moment. Let's- Getting it here. Okay. Let's go to full screen mode.
Okay,
the
much
slides are up.
appreciated.
Yeah.
Okay, I'll go ahead and start now if that's okay.
Go for it, Jeff.
Thanks, Christian.
Do you
Hello,
want to turn on?
everyone.
I'm sorry, Jeff, did you want to turn on your camera?
No.
Thanks.
All right. Hello, everyone. Thanks again for participating in today's work group meeting. My name is Jeff Lowry, and I'm CARB's lead staff for new off-road diesel engine regulations here in California. I'll be discussing potential amendments to the averaging, banking, and trading program for off-road diesel engines. Staff believes these amendments are necessary to prevent Tier 5 circumvention in California and to preserve competitive fairness among engine manufacturers under Tier 5. None of these potential amendments that I present should be considered official or final proposals at this time. Staff is looking for feedback on the concepts, including alternative suggestions from stakeholders, industry, and anyone who's interested that could help us accomplish our stated goals more efficiently. Next slide. Here's an overview of the topics I'll be covering in the presentation. First, I'll identify the background and purpose of the existing federal averaging, banking, and trading program. This is the program that California has been participating in since implementation of the Tier 1 standards. Next, I'll explain the need for an independent California averaging, banking, and trading program as part of the Tier 5 regulations. After that, I'll present some statistics illustrating why continued California participation in the federal averaging, banking, and trading program would not be reasonable under Tier 5, making it apparent why change is needed. Next, I'll present staff's concepts for an independent California ABT program. And finally, I'll discuss concepts that incentivize the early introduction of Tier 5 compliant engines in California using ABT credit multipliers. Next slide. Now I'll provide a historical perspective of California's participation in the federal averaging, banking, and trading program and the program's benefits. Next slide. Averaging, banking, and trading became a federal certification provision for non-road diesel engines in 1996 with the implementation of Tier 1 standards. The provision gives engine manufacturers the flexibility to continue certifying some engine families to less stringent emission levels by averaging their emission levels with other engine families certified to more stringent levels. This was meant to ease the transition to the new standards across product lines while maintaining the emission benefits of the standard on a national average. Manufacturers are currently allowed to generate and use credits for complying with particulate matter, oxides of nitrogen, and combined hydrocarbon and oxides of nitrogen exhaust standards. Next slide. California is presently a participant in the federal ABT program, along with the other 49 states and US territories. California does not require separate averaging accounting within state borders, primarily because California off-road diesel engine emission standards are currently aligned with federal non-road diesel engine emission standards, making disproportionate usage of ABT credits by manufacturers unlikely, or by state unlikely. Averaging banking and trading provisions do not have an end date, meaning that manufacturers can continue certifying less stringent engines indefinitely, so long as they have enough ABT credits to offset the excess emissions. Unlike the flexibility provisions for equipment manufacturers, which ended after 7 years, ABT goes on forever. It's not mandatory, but it is available on a perpetual basis for manufacturers willing to certify to it voluntarily. The current ABT program allows manufacturers to bank credits that they generate in excess of those needed to certify their engine families in a given model year. This is potentially a good thing for the environment because it means that manufacturers are producing more cleaner engines than required. However, the long-term effects of banking credits can also have a negative effect on air quality, as I will explain later in my presentation. The use of non-road ABT credits are relegated to two averaging sets, one below 560 kilowatts and the other above 560 kilowatts. Credits generally cannot be averaged or traded across these averaging sets. This was established as part of the Tier 4 rulemaking to minimize the use of credits generated by engines without aftertreatment to certify engines with aftertreatment and with significantly more stringent standards. Some manufacturers have accumulated substantial amounts of bank credits over the first 4 tiers of off-road diesel engine emission standards. Bank credits do not expire under the current ABT provisions. US EPA limited the use of ABT credits for certifying Tier 4 engines to primarily those credits that were generated from engines complying with the previous tier standards. This was done to minimize the proportional effects of using credits generated by engines without aftertreatment to certify engines with aftertreatment, and again, with significantly lower standards. The tiers that were allowed under Tier 4 were generally Tier 3 or Tier 2 when Tier 3 wasn't available. Can you flip the slide? Thanks. Although I've covered some of the benefits of ABT already, here they are in a nutshell. ABT improves the cost effectiveness of the regulations. Instead of devoting resources to making every engine compliant with the new standards, manufacturers can choose to over-design some engine families to standards more stringent than required in order to continue producing some engine families that conform to the previous standard, for which no additional development resources would be necessary. For the same reason, ABT can provide manufacturers with more time to phase in new standards over their entire product line, which may be especially important for engine family used in difficult or challenging applications. ABT maintains emission stringency on average, which means that the same emission benefits can be achieved on average at a lower cost to industry. And my personal favorite benefit, ABT incentivizes the development of cleaner engines than required, which can be used to set more stringent standards in the future. Basically, it's doing our demonstration programs for us in some cases when the FELs are significantly lower than the standard. Next slide. I'll now explain some problems with continued California participation in the federal ABT program and staff's conceptual solution to these impediments. Next slide. At this time, it does not appear likely that US EPA will adopt similarly stringent Tier 5 standards for non-road diesel engines nationally, as are being considered by CARB for board consideration in 2025, with implementation as soon as model year 2028 or 2029 in California. The current nationally aligned Tier 4 standards enable California to participate in the federal ABT program without undue concern that manufacturers will disproportionately use their credits to certify a preponderance of less stringent engines within the state. However, California's intent to adopt Tier 5 standards potentially changes this dynamic. Because the federal averaging banking and trading program does not include averaging provisions for greenhouse gas pollutants, and because federal credits do not have to be used proportionally by state, there is substantial risk that manufacturers with substantially banked ABT credits could use those credits to significantly circumvent the implementation of Tier 5 compliant engines in California for many years. This will be illustrated in more detail later in the presentation. In addition to the environmental damage that potentially could be done by circumventing Tier 5, manufacturers with the most credits would have a competitive advantage over those without credits, who would have to comply with the Tier 5 standards while their competitors would not. This was never the intention of the ABT program. Next slide. Here's the equation for calculating credits used in the federal ABT program. Credits are calculated as the product of the difference between the pollutant standard and the family emissions limit of the engine family for each applicable pollutant. And this is multiplied by the sales volume of the engine family, the average power ratings of the engines in the engine family, and the useful life of the engine family in hours. And then finally, it's multiplied by a conversion factor to take grams to kilograms. The family emission limit is the manufacturer assigned emissions level of the engine and becomes the de facto standard for the engine family when certifying using the ABT provisions. The credit result can be either positive if the family emission limit is less than the standard, or I should say more stringent than the standard, or negative if the family emission limit is greater than the standard. Negative credits represent credit deficits and are the amount of bank credits that would be needed to certify that engine family using the ABT provisions. I'll provide some examples later in the presentation. Next slide. I'll now illustrate the effects that continued participation in the current federal ABT program could have on the Tier 5 program using federal statistics. ABT credit balances are considered confidential business information. Therefore, staff is taking great care to ensure that the illustrations on this slide do not violate the confidentiality of any manufacturer. Should individual manufacturers with bank credits wish to better understand staff's analysis resulting in these charts, we would be happy to meet privately with you to discuss the details. Using ABT credit balances and other data provided by US EPA, staff has calculated the amount of time on average that Tier 5 implementation could be delayed in California if the top 3 manufacturers with the most bank credits were to utilize all their federal credits to certify Tier 5 engines solely in California. Staff's calculations assume that all bank credit are used in California. They wouldn't be used in any other state. Sales volumes and average power ratings would remain the same, and that the Tier 5 family emission limit cap would be equal to the Tier 4 final standard. So from this chart, you know, you're not misreading it. PM credits, and this is an average of the top 3. So some are higher and some are lower than this, but based on this average, Tier 5 PM levels could be delayed for 274 years, as outrageous as that might sound. NOx credits could be delayed on average by 12 years, and some manufacturers by much longer than that. Next slide. Thanks. So what do the data tell us? If California remains in the federal ABT program, some manufacturers could potentially delay Tier 5 compliance for decades to centuries. No manufacturer could circumvent Tier 5 because of its vast accumulation of ABT credits. That could be enough to result in significant market shifts, as the manufacturer with credits would be able to bring products to market at far less cost than its competitors. This would be unfair to most manufacturers that do not have ABT reserves and who would likely lose considerable market shares to the manufacturers who would never have to invest in Tier 5 compliant engines because of their banked federal ABT credits. This was never the purpose of the ABT program. So again, what do the data tell us? The data tell us that California needs an independent averaging banking and trading program for Tier 5. Next slide. I'll now explain the elements of staff's conceptual California averaging banking and trading program. Next slide. Our conceptual proposal is based largely on the California-specific ABT program recently adopted by CARB in the heavy-duty on-road omnibus rulemaking. As such, averaging would occur at the state level instead of nationally. Existing federal credit balances would be split into separate federal and California-specific banks based on each manufacturer's percentage of sales. However, only credits generated from Tier 4 final and later engines would be allowed to certify Tier 5 engine families. This is particularly necessary to ensure that manufacturers with large numbers of federally banked credits, which come from all 50 states, do not use them exclusively in California to circumvent Tier 5 for many years. Staff is conceptually proposing to retain the existing averaging sets, the one below 560 kilowatts and the other greater than 560 kilowatts. Staff is also conceptually proposing to set the Tier 5 ABT FEL cap at the previous Tier 4 final standards. And this is being done to afford maximum compliance flexibility for the engine manufacturers. A sunset date or credit expiration period of 5 years is being considered to avoid excessive credit generation in the future that could impede the adoption of future off-road diesel standards. New ABT provisions for greenhouse gas pollutants such as CO2, nitrous oxide, methane are also being considered. To encourage early compliance with the Tier 5 standards, staff is proposing that engine families voluntarily certify to the Tier 5 standards sooner than required. If they voluntarily do this, they would receive more ABT credits via credit multipliers than they would under just the Tier 4 ABT program alone. Next slide, please. As illustrated in this slide, a California-specific ABT pool would potentially be created beginning in model year 2026. This pool would store credits generated by engine families certified to the Tier 5 standards earlier than required. Credits in this pool may only be used to certify Tier 5 engines with a family emission limit less stringent than the Tier 5 standard, beginning in 2029. Also beginning in 2029, the federal credit pool would funnel off a portion of its credits into the California-specific pool, equal to the California percentage of federal sales for each manufacturer. These credits would be immediately available to use beginning with the 2029 model year. Federal credits would no longer be available to use in certifying California engines after this date, nor would California-specific credits be available to certify federal engine families. Staff is open to alternative suggestions on how to transfer credits between banks that afford equity. Next slide. To encourage early compliance with the Tier 5 standards, staff is proposing that engine families voluntarily certified to the Tier 5 standards from 2026 until 2028 or 2029, depending on what the implementation date, the mandatory implementation date would be for Tier 5, would receive more ABT credits than they otherwise would under the Tier 4 ABT program. Any credits generated from certifying Tier 5 engines earlier than required would be stored in the California-specific ABT bank, but may not be used prior to 2028 or 2029 to certify Tier 5 or Tier 4 engine families. The credits accumulated from 2026 and onward can only be used to certify Tier 5 engine families in California after Tier 5 becomes mandatory. The multipliers were selected based on the number of potential years available to certify engines early to the Tier 5 standards after the regulation is approved by the board and signed into law. A potential 2025 board date is anticipated, with an effective date for the regulation beginning in 2026. Some of the omnibus multipliers are larger in magnitude because there are more years prior to the mandatory implementation date for their more stringent standards. That is 2031 for their final standards versus 2028, 2029 for Tier 5. The multipliers also represent reasonable credit increases for early compliance that won't negatively impact emission benefits down the road when the credits are likely to be used. PM emission control technologies are largely available for meeting the proposed Tier 5 standards. Therefore, we don't feel that additional PM credits via multipliers are warranted. There are no CO2 standards currently for off-road diesel engines from which to generate credits. Therefore, we're not proposing CO2 multipliers either. Next slide. Here's the conceptual equation for calculating credits under the California-specific ABT program. The equation is nearly identical to the federal ABT credit equation, except that sales volumes are based on California sales instead of federal sales, and it contains an additional factor applying a credit multiplier for engine families complying earlier than the Tier 5 standards. The multiplier would be 1.75 times for engine families complying with Tier 5 3 years early, 1.5 times for families complying 2 years early, and 1.25 times for families complying 1 year early. The multiplier becomes 1 or null essentially as soon as the Tier 5 standards become mandatory and thereafter, and the equation then looks nearly identical to the federal equation except for sales volumes. The multiplier would only apply to credit generation and would never be used to amplify credit deficits. Slide 18. I'm sorry, next slide. Okay, these next 5 slides illustrate hypothetical examples of credit generation and usage under the California-specific Tier 5 ABT proposal, or I should say concept. It's not an official proposal. In this first example, we have an engine family complying with the potential Tier 5 NOx standard of 0.04 grams per kilowatt hour 2 years earlier than would be required under our conceptual Tier 5 proposal. There are 250 engines in this hypothetical engine family, and the average power rating for the engines in the family is calculated to be 200 kilowatts. Useful life is 8,000 hours. Under current federal Tier 4 requirements, credit for the engine family would be based on the difference between the Tier 4 NOx standard and the FEL, which in this case is the potential Tier 5 NOx standard for this power category. So the Tier 4 NOx standard would be 0.4, and the potential Tier 5 NOx standard, also known as FEL in this case, would be 0.04. And that would result in a 0.36 grams per kilowatt hour basis for the credits. Now, going through the multiplication in the equation, the total credits for the engine family under the Tier 4 methodology would be 144,000 kilograms. However, under the conceptual Tier 5 provisions, credit would be multiplied by a factor of 1.5, resulting in a credit basis of 0.54 grams per kilowatt hour instead of just 0.36. Total credits for the engine family under Tier 5 would then become 216,000 kilograms due to complying 2 years ahead of time. That would be 216,000 kilograms because of the multiplier versus 144,000 kilograms if we were just to certify this under the Tier 4 program. These credits would be deposited into the California-specific ABT pool. Next slide. In this second example, we use the same hypothetical engine family from example 1, but only complying 1 year earlier than would be required under our conceptual Tier 5 proposal. All other parameters remaining the same as in our previous example, we end up with a Tier 5 credit basis of 0.45 grams per kilowatt hour versus the Tier 4 credit basis of 0.36 grams per kilowatt hour. This results in 180,000 kilograms of total Tier 5 early compliance credits versus the 144,000 kilograms of the federal Tier 4 provision. These credits would also be deposited into the California-specific ABT pool. Next slide. Again, we use the same engine family from example 1 in this third example, but here there is no early compliance. Because Tier 5 standards would now be mandatory, ABT credit would be based on the difference between the Tier 5 NOx standard and the potential FEL, which in this case would also be the potential Tier 5 NOx standard. So it would be 0.04 minus 0.04 resulting in 0 grams per kilowatt hour as the credit basis, and multiplying that through also results in 0 grams of credit. And this is because Tier 5 would be mandatory when this engine family was certified, and it's not being certified to a lower FEL, it's being certified to exactly the standard. Next slide. In this fourth example, we have an engine family complying with an FEL of 0.05 grams per kilowatt hour, which is just slightly less stringent than the potential Tier 5 NOx standard of 0.04 grams per kilowatt hour. In this example, there are 1,000 engines in the engine family, and the average power rating for the engines is calculated to be 65 kilowatts. Again, using useful life of 8,000 hours. In this equation, even though the engine is complying 1 year earlier than would be required for Tier 5 compliance under our conceptual Tier 5 proposal, it cannot be certified as a Tier 5 compliant engine because it would require credits from the California ABT pool that would not yet be available for use. California specific credits can only be generated prior to the mandatory implementation dates for Tier 5. They cannot be used. Under current federal Tier 4 requirements, credit for the engine family would be based on the difference between the Tier 4 NOx standard of 0.4 and the FEL of 0.05 grams per kilowatt hour. This would result in a credit basis of 0.35 grams per kilowatt hour and a total credit of 182,000 kilograms under the Tier 4 proceedings. So basically, even though it would be certified to an emission level far below Tier 4, it's not quite at Tier 5 levels. So we would not be able to provide the credit amplifiers, even though it technically would be certifying early, because it is not equivalent to or less than the Tier 5 standard. So the credits developed from certifying this based on the Tier 4 provisions would be deposited in the federal ABT pool. Next slide. And in this fifth and final example, we have an engine family complying 1 year earlier than the potential mandatory Tier 5 standard for its power category, but to the Tier 4 FEL cap. In this example, there are 800 engines in the engine family, and the average power rating is 465 kilowatts. Useful life is still 8,000 hours. Because the Tier 5 NOx FEL cap of 0.80 grams per kilowatt hour is higher than the conceptual Tier 5 standard of 0.04 grams per kilowatt hour, an early Tier 5 compliance credit multiplier is not applicable or available. Consequently, the credit calculation for this engine family would be based on the current Tier 4 ABT provisions. As a result of the engine family's FEL being less stringent than the Tier 4 final standard, a credit deficit of 1,190,400 kilograms would result. Credits needed to certify this engine family could only come from the federal ABT pool. The engine family, or this engine family, would not be allowed to be certified in California even after 2027, for 2028 and 29, when Tier 5 could potentially become mandatory, because its FEL of 0.80 grams per kilowatt hour exceeds the conceptual Tier 5 FEL cap of 0.04 grams per kilowatt hour. So this engine could never be certified as under the Tier 5 provisions as a Tier 5 compliant engine, even with credits. Next slide. Thanks. I'll now illustrate the effects of staff's conceptual California-specific ABT program on potential Tier 5 compliance days. In this slide, we see the average Tier 5 implementation delays that could occur under staff's conceptual proposal for the 3 off-road diesel engine manufacturers with the most ABT credits, should these manufacturers use all their credits to postpone Tier 5 certification in California. Limiting credit usage to those credits generated from Tier 4 and Tier 5 engines helps to level the playing field significantly with respect to the length of the delays permitted regarding Tier 5 compliance, as does splitting the pool into the California portion. Now, looking at it, you have a 9.6 month delay here for implementing Tier 5 NOx standard based on this average. That may be acceptable. We're thinking less than a year is probably acceptable for if you have bank credits, a delay of less than a year, probably acceptable. Unfortunately, we're still seeing an 8.4-year delay for the PM standard, and that's not acceptable. And furthermore, again, this is an average of the three manufacturers with the most credits available. The worst case manufacturer in this average could potentially delay NOx implementation and PM implementation by several decades. Again, this would likely result in significant market shifts as the manufacturer with these bank credits would be able to bring products to market at far less cost than its competitors. Next slide. Additional limitations on the use of bank credits are necessary to ensure a level playing field for all manufacturers under the California specific ABT program. We've made a big dent in it by creating separate pools and by limiting the use to Tier 4, but it appears that other mechanisms will be needed to reduce the delays further. One such method, the elimination of all previous credit balances, and then we would start new in California with the implementation of Tier 5. It's a potential option, but staff prefers to craft the California specific program in a way that continues to reward engine manufacturers for complying early with cleaner emission standards. So we would prefer to still maintain averaging and at least some portion of bank credits. But we're open to suggestions, and we request alternatives from stakeholders, and in particular from associations whose members consist of both manufacturers with and without substantial credit balances. That would be most helpful, especially given the confidential nature of the credit balances. Staff also requests feedback on the need for credit provisions for nitrous oxides and methane emissions, as well as reasonable methods for implementing such provisions if deemed necessary. Next slide. In recent meetings between CARB staff and the off-road industry, the concept of a combined tailpipe greenhouse gas standard was raised for off-road diesel engines. We've been exploring the concept, but request constructive feedback and suggestions from industry why a combined GHG standard is necessary versus discrete standards, or why it's preferred from an environmental perspective and from an industry perspective for the off-road, and how to construct such a standard for off-road engines, giving the vast differences in global warming potentials and lifetimes of the pollutants involved. Additionally, several manufacturers have asked staff to consider offering ABT credits for off-road zero-emission powertrains. We request feedback on how this can be accomplished in an engine regulation versus an equipment regulation, which will be coming down the line later on. Please also provide feedback on how ABT credits will increase the demand, the consumer demand for off-road zero-emission power cranes. This concludes my presentation. I appreciate your attention. I know it was a bit long, and I thank you again. Done, Christian.
Thank you, Jeff. Okay, we'll look into the Q&A here. See here. Dang-Hu Kim has a question for you, Jeff. If the engine manufacturers get NOx multipliers of 1.5 due to the 2 years of earlier certification for model year 2026 for mandatory compliance in 2028, would the NOx multiplier be the same as 1.5 for 2027? Or would it change to 1.25 for model year 2027?
Yeah, thank you for the question. Again, this is Jeff Lowry. It would change to 1.25. It's a different engine family, new model year, different engine family. That engine family is now complying 1 year early instead of 2 years early, so it would only get the 1.5 multiplier.
Thanks, Jeff. The next question is from Michael Reed. The agency is discussing ZEV, but have they also considered ZEPs for non-road?
Yeah, we're looking into, like I mentioned, we're looking into credits for zero emission powertrains for the off-road. Tier 5, though, it's an engine regulation where the credits they would affect the FEL of the engine. We do envision there being a powertrain certification procedure for zero emission vehicles, also possibly for hybrids as CARB continues to develop off-road regulations. Again, we're looking for feedback on how to make this work in an engine regulation. But to answer the question, we have been looking into it. We would certainly like more information from stakeholders on how to make it work on an engine basis.
I think we have one raised hand question from George Lynn.
Yeah, can you hear me, Jeff?
Yeah, we can hear you.
Hi, George.
great.
Yes, I can hear you. Thanks.
Yeah, thanks. I have a question on slide 15, and it's just not a critique, it's just a question. I'm just wondering about how the federal ABT, that pool of credits, translates to the California ABT. Is there a proportion of that federal ABT that gets separated and put into the California ABT, or is there some just drop dead transition, for example, model year 2026, where all federal ABTs just kind of go to zero as far as California is concerned?
The concept is to base this largely on what we did for in the omnibus rulemaking for heavy duty on-road, where we split the pools. My thinking at this point is that it would be split on it would be split in 2029 based on the percentage of sales, and that credits would no longer go into the federal pool for Tier 5 compliant engines after that. If there were still Tier 4 compliant engines that were allowed, they would still be under the provisions for federal Tier 4 compliant engines, until at which point EPA might align with California's Tier 5 requirements. Did that answer your question?
No, I don't. I'm not sure that answers my question. So I'm thinking that let's say in 2023, next year, right?
Okay.
The manufacturers have some pool of AB&T credits, and we'll call that the federal AB&T credit bubble, right?
Okay.
And so they will add to that or subtract from that as they gain or use AB&T credits. When we get to some year in the future, I don't know if it's 2026 or 2029 or when this transition occurs as shown on this slide, is there any portion of that federal AB&T credit pool that gets then attributed so that it's usable in California?
Again, if I'm understanding you correctly, in 2029, that's when we would split the federal pool.
Okay,
so California would it would be done on a manufacturer basis. So if a manufacturer's sales volume, the California sales volume was equivalent to 7.5% of the federal sales volume, that's the amount of credits that would go into the California pool for that manufacturer.
Okay, all right. So it would be based on maybe some average formula or scheme of past sales.
Right, correct.
And then and so if the thought is that this is going to happen in model year 2029, and in some of your future slides you talked about this credit multiplier, which I do have a second question on, but these credit multipliers that would be incurred or that would apply earlier. So those engines prior to model year 2029, those in, for example, model year 2026, 27, 28, that are generating credits, those would be California specific credits only, or do you foresee that? I mean, because I guess I would expect that if a manufacturer was producing an engine and it was lower emitting, they would be generating federal credits and California credits at the same time, right? And then so that engine generates, if it's in, for example, model year 2026, would generate California specific AB&T in that year. And then because it's at that point, let's say 3 years early, and then at the same time, it would generate federal AB&T credits that then would be again proportioned at 2029.
Well, the only engines that could generate credits prior to the mandatory implementation date for Tier 5, and I'm talking about California credits, would be those that are certified to the Tier 5 standards early.
Mm-hmm.
Now, if Tier 5 were to begin in 2029, and a manufacturer comes in, well, we're assuming 2026 is the date that Tier 5 will become effective. No
Yeah,
guarantee.
the regulations will be published, right? Yeah.
Yeah, right. So say, in 2026, a manufacturer certifies an engine. They don't have to certify it to Tier 5. They can certify it to Tier 4. Any credits that would be generated from that engine, assuming it's certified to a lower FEL than the standard, would go into the federal bank because it's still Tier 4. However, if the manufacturer were to certify it to the Tier 5 standard or earlier, beginning in 2026, they would be able to get the credit multipliers, and those credits would go into a California specific pool.
Mhm.
Okay, different than the federal pool. Those credits could not be used until the Tier 5 becomes mandatory, but they could continue to be accumulated from 2026 through 2029.
Understood. So in that scenario that you just talked about,
Mhm.
manufacturer certifies a Tier 5, a California ARB Tier 5 engine in model year 2026. They generate credits, the California specific credits, the CA-ABT credits in this case. But at the same time, that engine would be certified under EPA's Tier 4, most likely, right? And so that engine would also be generating the federal AB&T credits as well, would it not? I mean, I think that would be expected.
No, I don't believe it would be generating double credits like that. What we envision is that it only goes into the California pool.
Yeah, so how are you going to segregate that? Because I think a manufacturer, if they certify that for California, they likely will certify that with EPA as well, so that it could also be sold, in the other states, right? And therefore, in that scenario, there is and maybe you intended this, maybe you didn't, but there would be a little bit of a double dipping there, because the
Right.
California AB&T credits would also be accruing, and then later they get proportioned in 2009, or sorry, in 2029.
Yeah, George, I think this is an excellent question, and it's something we're going to have to sort out, because we definitely don't want, as you phrased it, double dipping. The intent was, if it's certified to Tier 5, which is a standard only for California, then those credits would go into the California pool. But I see your point, and that's
Okay.
something we'll need to work out.
Okay, and then my next, and I'm not for or against, or I'm just simply trying to ask for clarification here. And my second question related to this is, okay, I understand what you're saying about the multipliers. I understand the proposed values or the concept values, but what is the logic for those values? Like, what is the reason? I guess it seems a little unusual to have these multipliers. What was the logic behind that?
Well, the multipliers, it's kind of a carry across, if you will, from the on-road omnibus regulation, which also applied early compliance multipliers. The actual numbers, we've done some preliminary analysis in terms of the emission benefits from them, but what we're looking for is to provide an incentive to a manufacturer to bring in engines cleaner than required, earlier than required. So we would give them additional credits. We don't want to give too many credits that, okay, once Tier 5 becomes mandatory, now we're in a similar situation as I described earlier, where, manufacturer may not have to certify Tier 5 compliant engines for a year or two. So there's a balancing act, and we are definitely, open to suggestions if you think those multipliers should be higher or lower. But right now, that's kind of the methodology. We want to provide an incentive, but we don't want to provide too much credit, that it's going to affect things later on.
Okay, but like normally if a manufacturer were to produce the next tier of product earlier, they would get that emissions credit and it would come in at, essentially at one time, but they would just have more years if they sold it earlier, they would have more years to generate that credit, right? So if they came out with it in model year 2026, they would have essentially 3 years to generate credits. And so that would, kind of be baked into that. This seems to apply an additional kind of bonus or multiplier on that. And I understood you said that it's based on the on highway, but I'm just wondering what the logic or the justification reasoning was for that. Was it simply, just to kind of like, just further add incentive and that's all it was? Because on the flip side, you're not, for example, proposing a additional penalty if someone carries or uses credits beyond 2029.
Didn't understand that last part. We're not proposing penalties for using.
Yeah, like on one hand, you're just saying that if you come out with a lower emitting product sooner, you generate credits, and not only do you generate credits, there's a bonus on those credits, right?
Right.
But the flip side of that would be if there was something analogous, and I didn't hear it, but if there was something analogous to this, it would be, well, if you're consuming credits and you consume credits later and later on after model year 2029, the penalty gets bigger and bigger, right? That would be kind of the analogy of the credit generation and the credit usage. But you're not proposing that on the flip side. And so I guess I'm just curious as what was the incentive or driver to have these credit multipliers for products that are introduced early.
Jeff, maybe I can jump in
Sure.
here. Yeah, thanks. That's a great question, George. And I think part of what we're trying to do here, especially recognizing that, we've been working really closely with US EPA and we're hoping that they will come behind us and align quickly, maybe sort of parallel to what's happened on the on-road side. It is likely that we'll be adopting these alone in California and have them in effect here a few years ahead of when they'd be effect nationally, even in like the rosiest scenario from an air quality perspective. So given that, we really want to incentivize manufacturers to to take these standards seriously, to put engineering resources towards meeting them, to not pull out of California, for example. And so it's really to our benefit to have some manufacturers start early and show, sort of underline the technological feasibility of these standards. We've done a very extensive demonstration project at Southwest Research, but having some manufacturers certify early would sort of serve to underline the tech feasibility. So in addition to just getting straight emission benefits, I think there's a contribution to the success of the whole program if some manufacturers start certifying to these early. So that may help you understand why we think it's appropriate to have these multipliers that are greater than 1.
Okay, no, thank you for that. And then just a concluding question on this topic. For these, for an engine that's, for example, introduced in model year 2026 that meets the Tier 5 standards, or I'll call it the 2029 Tier 5 California standards, how does OBD work for that? Would OBD then be a requirement for that? Or if the OBD regulation maybe isn't quite finalized, those engines are produced in 2026 that meet the emission standards but do not have OBD would still generate the full credits?
So if I understand you correctly, George, you're asking if the existence of OBD is necessary in order to get the credit multipliers?
Or even to generate credits? Both credit multipliers and to generate credits.
It's something we'll take back and we'll consider. If I had to guess at the answer, it would probably be no, because I think OBD is probably going to take a little bit longer. I don't think we would see too many OBD compliant engines in 2026. But then again, it may be enough of a carrot to get us there. So it's a good question. Again, all your questions are good. I will take it back and give it due consideration.
Okay, great. Thank you.
Thanks. Our next question is from Michael Reed. Does the agency have a proposal to certify a hybrid solution? Today, if the electric side of the hybrid is physically separable from the engine, the only method is to certify the engine, for example, 19 kilowatts. For 19 kilowatts, even if hybrid solutions may produce around 37 kilowatts. I think Bob Nguyen would like to respond to that.
Thank you, Christian. Thank you, Michael, for the question. And the first part of the question that you have is whether we are planning to have a proposal to certify a hybrid solution. And the answer is no. Currently, we are not planning to develop any test procedure for a hybrid to be certified. We may take up on that for a future rulemaking if there is increased interest in having a certification procedure for hybrid. We do, however, in this Tier 5 rulemaking, are evaluating some concepts that would provide emissions credits for hybrids, off-road hybrids. And it's not a certification process that the credits will be determined, but more along the line of a verification procedure where the hybrid would be required to submit data through some sort of in-use testing. And we would verify the amount of emissions generated or reduced, which would translate to how much credits would be generated. All right, thank you.
Thank you, Bob. The next question comes from Bridget McClevey. For engines certified with ABT credits, has there been a study done to determine the effect and cost years down the road as ABT vehicle tries to pass recruiting frequent smog tests to meet increasingly more restrictive emissions? Has any consideration been given to the number of consumers impacted by the ABT programs and an owner's cumulative costs as a result of the ABT program? Rather than implementing another detailed complex program for Tier 5, why not require a phase-in by volume as a % of vehicles sold in California? That way, manufacturers can gear their production by models and engines characteristically sold in California.
I can try and take a crack at this one too, Christian.
Thanks, Jeff.
Yeah, if I understand the question correctly, I guess there's multiple elements to it. She wants to know if a study's been done to determine the cost effectiveness or the costs and the effect in costs years down the road as the vehicle tries to pass recurring smog tests. Well, there are no smog tests, at least not yet, for off-road diesel applications. So there hasn't been a study specifically aimed at determining that aspect of the question. ABT, what it does is it allows some engines to be certified that are dirtier than the current standard, so long as an equivalent amount of credits have been generated from other engines that are cleaner, that offset this. So on average, the emissions remain the same. I don't know how this would affect the owner's cumulative costs, the ABT program. Now, ABT, it's not a program that California is creating. It's a program that EPA has administered for many years, since 1996. What California is proposing is that instead of the averaging being done at the federal level for all the states, that the averaging would be done under Tier 5 at the state level. Other than that, the equations as I presented are nearly identical. The process would be nearly identical. I'm not sure that a phase-in would make sense or even be necessitated for ABT because, again, it's a provision that's intended to help manufacturers comply easier and more cost effectively because they don't have to devote resources to convert every single engine. I hope that answers the question. I don't know, Kim, I saw something pop up. I don't know if you'd like to chime in as well.
No, I didn't have anything else. Thanks.
Okay, thanks. Next question, Christian.
Oh, sorry, I was muted. The next question comes from Steve Berry. Is CARB entertaining the possibility to certify a full Tier 4 final engine after Tier 5 goes into effect? That is a Tier 4 final FEL without LLC, 3-bid moving average window, and OBD?
Well, I guess I'll try and answer this one too. Have we entertained the possibility of a full Tier 4 engine after Tier 5? We've mentioned small volume manufacturer provisions that we're considering, which would be almost the same effect of allowing a Tier 4 final engine to continue to be certified by small volume manufacturers. It's entirely possible that we could put life back into the flexibility program for some manufacturers where they could install a Tier 4 final engine in the Tier 5 timeframe. None of this has been, completely vetted out. These are just concepts. But I guess to answer your question, Steve, is that, we have under certain circumstances looked at the possibility that Tier 4 final engines may still be around in the Tier 5 timeframe in some form or another.
Okay, I think that's all the questions I see in the Q&A section, and I don't see anyone raising their hand. Maybe we'll wait a few moments here, see if we have any more questions before we move on to the next topic. Oh, I think we have a hand raised from Chris Walters. You could unmute yourself, Chris.
Yeah, can you hear me now?
Oh, I can hear you.
Okay, thank you. So I had a question, if you've talked to EPA at all about the California only AB&T bank, and kind of have you thought about how you transition from today's paradigm of the federal program to having a EPA only program and a California program?
Hi, Chris, this is Jeff again. We've briefed EPA on our proposal, and we've briefed several members of their staff. We actually sent the presentation to them, asking them to review it ahead of time. I can't say that they're comfortable with the presentation, but they know where we're headed. It's based similarly on what we did in Omnibus that was approved and ratified. But again, we're open to suggestions. We're definitely open to suggestions from you and from EPA on how to make this better. But we're looking at ABT just for engines that would be certified in California. They wouldn't, they don't necessarily need to be certified federally. And obviously it wouldn't include preempt engines either. They wouldn't be part of the ABT program. So that's how we envision separate programs, if that answers your question.
Yeah, Jeff, maybe my question isn't a good one, but what I'm thinking about is, today let's say I'm a manufacturer and I am certifying engines to generate credits and I'm using them, and the state in which they are, the product is sold is sort of a moot point in terms of how I calculate and maintain my credits. But when I go to this new program, I'll have two separate, like you mentioned, no problem. I understand how that would work. But how do we transition that? I mean, it doesn't come to my mind, and it's not necessarily that you have to answer right now, but maybe it's something to take away as just one of the boxes that need to be checked in terms of, okay, we have to get from point A, which is today, to point B, which is your vision of how it would be two separate banks in the future. How do we make that transition while allowing us to still be able to sell products? If, because a lot of the credits are being generated on current product and used on current product today. So I just want to make sure we don't get stuck in some way where we have a gap in credits because of this transition. We need to make sure that we accommodate the transition in the proper way. And maybe the model is whatever is being done on the highway side, but maybe it isn't because of the preemption. Maybe that's a reason to consider something a little different, or whatever the reasons may be. So just something up for the radar, I guess, to keep in mind. Not that I expect you to be able to answer it off the top of your head, but
Well, no,
if
sure.
that makes any sense, I guess that's what I'm worried about.
And I know I fully appreciate the question. Certainly we'll consider it. What are and again, yes, we are basing this on the on-road, the omnibus methodology that split the credit pools. What are the transition issues that you're thinking of? What are you thinking that we would need to, phase in? I'm not seeing that at the moment.
Yeah,
To me, it's like if you certify a tier 5, then any credits would go into the California pool, because tier 5 would only exist in California unless EPA aligns, and then that changes things, dramatically as well. But yeah, so the credits would only be for California, and they would only be used for tier 5 engines. But I'd be curious to hear, what issues you envision regarding a transition.
Yeah, I guess I'm thinking of that first year, and if I have a product I'm selling in California, but I would like to use credits that I generated at the federal level, I can't do that anymore, but I don't have any credits banked to start with in California because it's a new program. So I'm trying to understand how I get off the ground. I guess I'd have to do an averaging where I use all the credits I generated in the same model year, so my debits and credits would have to be equal. Doesn't seem quite fair when in reality, the credit balances. I mean, the beautiful thing about the ABT program is it's a net zero program. The number of credits consumed is the number of credits generated. So if I'm going to lose out on some of my bank credits that I can't use in the first year of California only program, or something like that. Anyways, I'm going on. The gears are just turning in my head, so it's not.
No, this is good. I
yeah,
appreciate your
yeah.
question. And I think I have a partial answer, is that we're proposing to split the federal bank based on sales. So you would have available a portion of those credits to use in 2029 based on what that split gives you. But again, if you have, and if you have ideas on how to make this even better, please let us, by all means, let us know. A smoother transition. Thank you.
Yeah, that's maybe something I missed that maybe answers most of my question. But we'll certainly be evaluating this from every angle, and if we see some things that we think need to be addressed in how you manage the program. But yeah, good start, and we'll follow up if we have more thoughts.
All right, thanks, Chris.
Okay, Chris seems to be our last comment, and there's no new questions in the Q&A section. So maybe it's best we move on to the next topic.
Christian, I don't actually I think that now would be a good time to take a lunch break, because that's what we had on our agenda.
I'm sorry. Thank you for reminding me.
Okay,
Fantastic.
so let's stop now. Take 35 minutes and then rejoin at 12:35 after we take a 35-minute lunch break. Make it even at 12:30. You can put a note back on the slides that we'll be back at 12:30, and then we'll cover the idle reduction.
Sure, that sounds good.
All right, thank you, everybody.
Returning at 12:30. Hi, everyone. Welcome back from the lunch break. I think we're ready to get started with our third discussion from Shinakao on idling reduction. So Sean, you're free to share the presentation.
Hi, Christian. It looks
Hi.
like I'm unable to share from my side. Can you?
Oh, sure, no problem. I can do it.
Maybe Shun, could you start out just introducing yourself so folks know who they're
Okay.
hearing from?
Yeah. So my name is Shun Nakao. I'm from Mobile Source Control Division and on-road heavy-duty diesel section. Today I talk about the idle restriction, our staff's concept for idle reduction in Tier 5 rulemaking. And just like any other presentation, this is our current steps thinking, and then we would love to hear your alternative concepts. Okay, and now I see the presentation, and thanks. So let's get started. Christian,
One
next.
second, let me change it to a full screen. I think I might have to close this.
Oh yeah.
Thank you for your patience. This looks better. Okay, there we are.
All right, thanks. So I like to start with talking about what kind of idle reduction requirement exists in off-road, specifically in use off-road diesel regulation. And then I'll talk about why it's important to control idle NOx emission. And then I'll introduce our potential idle reduction concepts and the current staff's thinking behind it. And I'll talk about definition related to idle. And then lastly, I reiterate some of the points where we are asking for feedback. Next slide, please. So idle reduction requirement exists in the in-use off-road diesel fuel fleets regulation in California. And the requirement is 5-minute idle restriction. An affected fleet must have a written idle policy, which has a number of exclusion criteria, including idling during curing, for testing, servicing, repairing, and so on, listed here. And again, this is in-use requirement. And then California and US EPA's existing standards for new off-road engines do not include idling restrictions, which is what we are going to consider in Tier 5 rulemaking. Next slide, please. So regarding the importance of controlling idling NOx emissions, this slide intends to give you the idea of how important idling emission can be relative to non-idling emission. So first of all, based on available information, idling is common for off-road equipment and potentially around 30 to 50% with respect to operation time. And we got this information from some manufacturers, as well as 3 different data sets used in CARB's inventory. And with respect to emission, the current off-road emission inventory of CARB does not isolate idle emission because it uses the average load factor for the entire operation. However, even without detailed inventory simulation, we still think it's important to consider idle reduction because idle emission could potentially dominate the overall NOx emission if idle emission rate is much greater than non-idle emission. And the example below illustrates the point. This example is a simple back of the envelope type calculation showing the idling emission versus non-idle emission. So let's consider a 560 kilowatt engine meeting a 0.04 gram per kilowatt hour potential Tier 5 NOx standard, running the non-road transient cycle or NRTC, in which the average load is 37% of the max engine power. So here we are using the NRTC as an example of non-idle operation. And the question is, what is the non-idle emission rate? And so to calculate the potential Tier 5 NRTC NOx emission rate, we have to multiply the potential NRTC standard, 0.04 gram per kilowatt hours, and then the actual power generated by the engine, which is 560 kilowatt, and the average load 37%, which equals to 8.3 gram per hour. Whereas the current on-road heavy-duty idling NOx standard is 30 gram per hour, which is significantly greater than 8.3. So this simple example shows that idle emission could overwhelm non-idling emission unless idling emission is improved from the current level of the current diesel engines. And of course, this is a simple example, and then off-road is extremely diverse. Again, the intent of this example is to show that when non-idle emission becomes low, the idling emission has to at least approach that level. Otherwise, idle emission could overwhelm the overall emission. Next slide, please. So here is the potential idle reduction concept. As a starting point, we have two compliance options like the idle reduction requirement for on-road. The first option is to use a non-programmable 5-minute engine shutdown system. And for on-road, there are a number of overriding conditions, including idling during power takeoff, idling when engine coolant temperature is less than 60 Fahrenheit, idling during after treatment regeneration, or idling during service or maintenance. So we would like feedback whether these overriding conditions are necessary or sufficient for off-road. And then another thing to note is safety concerns. As you can see, safety concern is not part of the overriding conditions for on-road, but we are aware that the safety is a major concern for having engine shutdown system in off-road application. So we would like feedback regarding safety or any other concern for having 5-minute engine shutdown system as one of the two compliance options. And then the second option is to comply with the NOx idle standard. And I will discuss NOx idle standard more in detail in later slides, but in a nutshell, we are considering setting the idle standard such that idle emission rate will be comparable to non-idle emission rate, so that idle emission doesn't dominate the overall emission. Therefore, we are considering setting the standard as a function of engine power and corresponding NRTC standard, and here using NRTC as a representative or as an example of non-idle operation. And then we are asking feedback whether the 5-minute shutdown system option is needed for off-road. And okay, so we're going to discuss the rationale for potential idle NOx standards, although we touched on some of the points briefly. In the recent on-road heavy-duty low NOx omnibus regulation, the idling standard for heavy-duty diesel engine is 5 gram per hour for model year 2027 and later. And we view it as a point of reference, but we are aware that there will be issue if we simply apply the same number to off-road engines, regardless of power, because first, Tier 5 engine must account, Tier 5 standards must account for different power categories. And then within each power category, there's a wide range of power. For example, there's factor of 10 difference in engine power in 56 to 560 kilowatt category. which potentially creates a greater challenge for a larger engine to meet 5 gram per hour emission rate. So we think it's important for potential idle NOx standard to consider the wide range in engine sizes. Next slide. And again, to ensure the idle emissions do not dominate the overall emission, we think idle emission rate of an engine should be comparable to its non-idle emission rate. And then the question is, what is non-idle emission rate? And of course, there is infinite number of non-idle operation profiles, but we think NRTC is a reasonable middle ground for the extremely diverse off-road operation profiles. Therefore, we are considering setting the potential idle standard as a function of maximum engine power and the corresponding NRTC standard and its average load factor 37%. And then using the same example from an earlier slide, you can consider a 560 kilowatt engine. So in this example, that we can calculate the NRTC emission rate and corresponding idle standard. So the calculation would be that NRTC's standard 0.04 gram per kilowatt hour times its power 560 kilowatt and its average load 37%, which equals to 8.3 gram per hour. And then we are considering rounding it up to the next integer, 9 gram per hour. And then we are also considering having a floor and ceiling to the potential standard. We are considering 5 gram per hour, which is the idle standard for the on-road heavy-duty diesel engine model year 27 or later to be the minimum or the floor, and then 50 to be the maximum or the ceiling. We are considering exempting engines exclusively designed for generator sets and transport refrigeration units, since they're not expected to idle and they have their own duty cycle. Next slide. We do have preliminary demonstration results at Southwest Research Institute. So using the methodology I described in the earlier slide, the potential idle standard for the demo engine with max power 187 kilowatt will be 5 gram per hour because it hits the floor. Then the test results for the off-road demo engine at Southwest showed less than 2 gram per hour of idling emission after 12,000 hours equivalent of hydrothermal aging, which doesn't involve chemical poisoning. So we keep an eye on further testing conducted at Southwest Research Institute. Next slide. So before we get into the potential idle standard, I'd like to show the summary of Tier 5 potential criteria pollutant standards that applies to NRTC and steady state cycle for your information. And again, the potential idle standard will be based on NOx standard for that applies to NRTC times its power and 37%. With floor of 5 and ceiling of 50. Next slide. So this is the graphical representation of the potential idle NOx standard based on power. So if you look at the middle range from 56 to 560 kilowatt, the idle standard shown in red hits the floor 5 for lower power range, and then it increases to 6, 7, 8, and 9. And then if you look at the lower power range from 19 to 56 kilowatt, the idle standard increase because the corresponding NRTC standard increase. And then idle standard changed linearly as a function of power with rounding up to the next integer. And then on the other side, for greater than 560 kilowatt, the idle standard increase and then hits the ceiling, which is why it is constant at 50 gram per hour. Next slide. So this is the same information presented in a table. And again, the potential idle standard is based on the NRTC NOx standard times 37% times the power, maximum engine power for the engine family in kilowatt, with the floor 5 and with the ceiling 50. And then the column on the right shows the numerical range, minimum and the maximum for each power category. We are considering exempting engines less than 19 kilowatt and then TRU and gensets. Next slide. So I've been talking about idle, but I haven't discussed what idle is. So this slide shows the definition of idle speed. I'm not going to read the whole definition. This is for your information. But I'd like to point out that idle speed is defined, but idle load is not explicitly defined. And then load often comes up as an important question when discussing idling in off-road. Therefore, we would like feedback regarding the need to add or modify definitions related to idle. Again, idle speed is defined, but idle load is not explicitly defined. Should we define idle load for off-road equipment? Next slide. Here's the potential test procedure. For on-road heavy-duty diesel engines, there is a test procedure to determine the compliance to the on-road idling standard, and we look at it as a starting point. So tentatively, there is a 2 mode duty cycles. In mode 1 is manufacturer recommended idle speed for 30 minutes. And then mode 2 is 1100 RPM for 30 minutes. Having said that, we are aware that the mode 2 for on-road was intended to represent the hoteling of long-haul trucks, which may not be directly relevant to off-road. So we would like to receive feedback regarding the need for mode 2. We are open to consider just mode 1, not mode 2. Regarding load, the engine manufacturer shall determine the appropriate test load for operating engine accessories such as fans, pumps, or compressors. And we would like feedback first regarding mode 1. On-road test procedure refers to mode 1 as curb idle, but obviously there is no curb in off-road. What is the preferred term for off-road? And we would like feedback on any challenges associated with using the heavy-duty diesel engine test procedure for off-road. Should the duty cycles be modified? Or should there be an upper limit to the test load? For example, 10% of max power. Next slide. Okay, lastly, I would like to reiterate some of the points we're asking for feedback. Of course, we request feedback regarding the potential concepts, including the standards. Again, idle speed is defined, but idle load is not explicitly defined. Should we define idle load? Alternatively, should we set a max load percent in the test procedure? Are there alternative ways to define the idle standards that account for the wide variation in engine size? I'd like to hear your alternative concepts. Is there a preference in the idle standard unit, gram per hour or gram per kilowatt hour? And with that, I'd like to thank you for your attention.
Thank you, Shun. Let's go look at the Q&A. The first question
Christian, I can take the first one. For some reason, the first one's already marked as answered, but it's not really answered yet. So this was a question from Michael Reed, who said, any details or discussion on clean skies related to idle reduction? If Mr. Reed is still on, it'd be great if you could clarify what he's asking about. He may be asking about blue skies standards, which are a set of voluntary standards that are more stringent than the mandatory ones that EPA has had in the past. And this proposal doesn't relate to that. This would be a mandatory part of our Tier 5 emission standards. But if Mr. Reed was talking about something different and I'm not answering the right question, please either raise your hand and talk to us or type another question. Thank you.
Michael Reed is here.
Yeah, I'm still on, and you're correct. The misnomer on my part, sorry. Blue skies was the intention of the question.
Okay, thank you.
Thanks, Michael, and thank you, Kim. The next question here comes from Saeed Abulashan. What application has the 30 to 50% idle time during the actual operation? And I think Yitan would like to speak to this.
Yes, we have the data submitted by OEMs, and we noticed that for some cranes, forklifts, and also some other construction equipment, they have 30 to 50% idle time. We also collected real-world activity data from various contracts and resources, and we have over 20,000 hours of real-world data, and the average the total idle time is about 23% of the entire operation. I hope this answers your question.
Thank you. The next question comes from Jung-Ho Kim. In the case for under 19 kilowatts, has CARB required fully electric for Tier 5? There is no emission limit under 19 kilowatt on slide 10, but there is a limit on slide 9.
Hi, so regarding less than, I'm Shunako again, regarding the less than 19 kilowatt, it is likely that this category will be electrified, but we do have a Tier 5 standard that applies to NRTC and steady state cycle as an initial concept. And then regarding for idle standard, our current thinking is to exempt this category from idle standard because this category is likely to be electrified, and also this category generally doesn't have an EGR, which would be an important strategy for controlling idle.
Thanks, Shun. The next question comes from Robert Hasselbrook. The question of idling limits and safety are very complex, and I really need time to visit with my operational staff on this. Will you be sending out relevant slides so I can call with my team and collect thoughts to bring back?
Hi, yeah, this slide is already posted on our Tier 5 webpage. So if you're interested in the slide, you're welcome to download it.
And I can just add that, this is a work group meeting, and we're very eager to hear folks' feedback and opinions, and nothing really that we've presented today is set in stone. We're still probably almost a year out from putting together the actual staff proposal and staff report and all that. So please, if you need time to think about anything we presented today, and then you want to circle back and talk to us one-on-one, please do that.
Thank you, Shun. Thank you, Kim. Right now, I'm not seeing any new questions in the Q&A chat, and I don't think anyone is raising their hand for another question. So I think we'll wait a few moments here for any questions on idling. Oh, I think we have one here from Jung-Ho Kim. There are expectations for idle limitation for fleet regulation like queuing, maintenance, and safe operation, and also the responsibility of idle reduction is on the owner or renter. Will these exceptions and responsibility be the same as Tier 5, or are there any differences? I think Shun would like to respond to that.
Yeah, so the idle limitation, I believe you're referring to, is the in-use regulation, and then Tier 5 is the engine regulation. So this will be a separate rule. So yes, so the Tier 5 will not change what's in the in-use regulation. I hope that answers.
Thank you, Shun. Well, if there's no further questions within this subsection, I think we can go to the Q&A for all the topics. So, if there are more idle questions, we can continue answering them in the next session. So, so we'll move on to the
There is a
questions for-
hand raised, Christian. Yeah.
Oh, thank you, Muslim. We have a question from Xavier Fashan.
Yeah, good afternoon. Just a quick question on idle. So it's there are cases where the machine, the equipment, is setting an idle speed that is higher than the engine certified idle. So I'm not saying it's a problem, but how do you see that type of situation? So for example, you'll have the engine may comply to an idle standard, whatever it is, whether it's 5 minutes or an actual limit on the NOx per hour. But on that particular machine, the engine will never idle per se. There is still the fleet regulation, but it's not necessarily talking about the same idle speed. So is it something you've considered, or is there any concern, any issue with this type of situation?
Hi, I can try to take a crack at it. What we are discussing today is the engine certification, and then but the equipment may require different idle speed, and that would, I believe, that would impact the in-use testing. So that's something we will probably have to think more when crafting our in-use testing requirement.
So you said in the in-use testing, you'll consider that whatever idle speed is actually programmed on that machine, that would be the idle considered for in-use testing. So not necessarily the idle speed that has been certified for the engine. Do I get that right?
So it is a initial concept, but the in-use testing is based on load. So based on load, idle or idle-like operation may fall into the lowest load bin, regardless of speed setting. So the idling at different speed might fall into the same bin that's subject to the same off-cycle standard. So that's something we need to consider when crafting in-use testing requirement.
Yeah, just not to make things more complicated. So my question was about the idle speed, but there is also, as everybody knows, the same concern about the actual load. So some machine, depending on the equipment, may have significant parasitic load on significant load at idle, whatever is this idle speed. So again, depending on how you set those idle conditions, a given machine may never idle per se, either because it doesn't go as this engine certified idle speed, or because the load is much higher than whatever limit was defined for idle condition. So it's more an observation, not saying it's a concern. But all right, thank you anyway.
Thank you.
Thank you, Xavier. Next question comes from Michael Reed. When considering idle time and idle reduction, there are numerous machine safety requirements that OEMs may comply with. For example, EU Machinery Directive, soon to be machinery regulation, telehandler with man platform. Mitigation to safety concerns may depend on running engine regardless of load to maintain hydraulic system performance and allowing a maneuver to take place by the operator. What data may be needed to share with the agency to declare idle reduction override? It is not really the same situation as on highway emergency vehicle or non-road emergency vehicles. I think Shun would like to respond to that.
Yeah, so that is the the kind of question we would like to receive feedback on, and we would like to certainly like to consider safety as a one of overriding condition, but what kind of requirement do you think feasible or necessary? And if you could provide us more detail, that would help us craft more better requirement for overriding condition. So yeah, so if you have more information, please provide us more. Please provide. Thank you.
The next question comes from Kanji Namimatsu. It seems that idle NOx standard is based on test data. Do you know if after treatment system works well, exhaust temperature is warm enough in this temperature?
Yes, so at this point we have a preliminary test result, again done at Southwest Research Institute, and it appears that the thermal management strategy employed in the demo engine was successfully able to manage the temperature enough for after treatment system. But that is something we and then Southwest will keep working on and keep an eye on. And as they age their after treatment system, we will receive more relevant or representative data for this demonstration project.
The next question is from Iro Kodamaki. Will there be a preparation cycle defined before the actual idle test procedure takes place? Is idling after cold start planned to be regulated similarly as idle with a warm engine?
Yes, so again, tentatively we are looking at the on-road test procedure as a starting point, and then on-road test procedure has the preparation requirements or preconditioning requirements. So the engine will be warmed up before undergoing this idle test. So yes, it is a warm idle.
Okay. Next question from George Lynn. Will constant speed engines be excluded from idle requirements?
And yes, I believe that's our current thinking, because we don't expect them to idle significantly. But if you have any information or any thought, we would love to hear your thoughts. Thank you.
Okay, I'm not seeing any new questions or hand raises right now, so maybe it's okay to move to the open-ended Q&A section. Oh, I think, sorry, Kanji Namimatsu has another question here. Off-road engines need the same override conditions as on-road. In addition to the above, it is dangerous to activate the auto idle stop when work equipment and traveling safety is not ensured. Many construction equipment models currently employ an auto idle function, but the auto idle stop is activated in a safety secured condition. Safety is ensured when the operator activates the work equipment and travel lock levers. The above is just a comment and wanted to
yeah. So thank you for your comment.
Thank you, Kanji. Okay, so now we can move to the all topics, questions, and discussion. The Q&A section will be, we're open to answering any questions for any of the topics we heard today. We'll keep an eye out for
Okay.
those who are raising their hands.
Seems there is one more, Christian.
Oh, sorry.
Raise hand.
Have a raised hand. Oh, okay. Ryan Vicente, ask you to unmute.
Yeah, thank you. I just wanted to make a quick comment that for emergency generators, especially ones with pretty well-defined maintenance programs, data centers and such, a large majority of their operations are at low load, 10%. And so you might consider that and whether or not to consider implementing the idle requirement on those engines, since often they don't have a lot of power outages. So majority of their emissions actually end up in the maintenance mode and testing mode. Thank you.
Thank you, Ryan. So we'll stay open here. I currently don't see any new questions or hand raises. If I missed anything, anyone can please let me know. We have a question from Jung Ho Kim. In case of a data stream, should all CCM input and output components signals send telematics or send via telematics? We'll give a second for our OBD team to digest it before responding.
Yeah, so that I guess that this question seems like it is goes beyond maybe more than the real data that's, I guess, being talked about being sent telematically as part of the in-use compliance screening program. Right now, we're not looking at sending all the CCM input and output signals via telematics. We'd really just be looking, or our current thinking is that it would be limited to a connected, broadcasting that data through a connected scan tool.
Okay, thank you, Mike. Still open to any Q&A. As a reminder, if there's anyone joining us by phone only, you can press #2 to raise your hand and *6 to unmute.
we can give people a couple more minutes or 1 more minute. Otherwise, we can close out the work group meeting.
Jenny, you're going to talk about next steps and timing, right?
Yep, I can talk about this right now. So anyhow, our next steps are to continue to meet with stakeholders on a one-on-one basis to discuss Tier 5 concepts. And that's what we've been doing for the last couple of years, but more so this past year in 2022. We have follow-up meetings with folks because there are so many concepts, and we continue to request feedback and data on what we presented on today. So just to recap, we're scheduled to go before the board in 2025 with implementation in 2028-29. Additionally, as I mentioned at the beginning of the work group meeting, our contractor 44 Energy has sent out cost surveys to engine manufacturers as part of our cost analysis. So please continue to send those in. They have received survey responses, but they're still accepting outstanding surveys. And I think they've been working with folks, so you guys know who you are. But for those who are wondering, if you have not been in contact with 44 Energy and you still want to send something in, there's still time to do so. Additionally, if you haven't subscribed to our website, for notifications of upcoming work groups and workshops, please do so. You can go on our website, and then you of course can email the OBD folks. Their email is on their presentation, and if you have non-OBD questions, you can email us on the Tier 5 ARB .ca.gov email, and we do check that, and we have been receiving a lot of questions on that. So continue to keep sending that. If we haven't reached out to you for for meeting with us one-on-one, please feel free to send us an email if you're interested in meeting with us. We're trying to get to as many engine manufacturers as possible. But we understand we're not able to hit everybody. So, please feel free to invite yourself. If we haven't invited you, we're definitely interested in speaking with you. So, are there other questions that
it
have
looks
come
like
in?
we
I
have
see one more.
Yeah. Jung-Ho Kim asks, for idle reduction, even though the engine has a function to limit idle after 5 minutes, would the idle emission limit be adopted or not? Ishan would like to answer that. Sure.
Okay, so this is, so even today's engine, we are aware that some engine do have a function, and some owners activate that function as an option. The compliance option we're considering is have the engine shutdown as the default instead of owner's option. So if manufacturer choose that option, then the idle standard does not apply. This is what we mean by the two option. It's if manufacturer choose the option 1, option 2 doesn't apply. But again, this is that initial concept, and we would like to hear feedback.
All right, and then one thing that I didn't mention is that we will need to be having a work group meeting next year on some topics that we have not covered yet. And those topics include SCR inducement, or just inducement in general, I should just say inducement, as well as warranty and useful life. So that's upcoming in 2023. We don't have a date for those yet. We've got some data that we're still analyzing. So I can't give you a date, but I can give you some topics. So that would be inducement and warranty and useful life.
And we'll definitely be talking more about low load cycle as we get that further developed, and also discussing further our in-use testing proposal that I think we've already shared some externally.
Yeah, we actually did already have a work group on our in-use proposal, but we can, you know, we can definitely think about having another one, specifically digging more into telematics. All right. Well, I don't see any questions. Muslim, are there any hands raised? Because I know you can see it, but I can't.
No, I don't see any.
Okay. Well, on behalf of the Tier 5 team, thank you so much for attending today's work group meeting. It wasn't as long as we anticipated, so that's good for everyone. And we appreciate your engagement on Tier 5. It's been great to date, and we look forward to continued engagement and more data in 2023. So thank you again.
Happy
And
holidays, everybody. And if
Yeah.
anyone prefers to speak to us like one-on-one, just reach out. We're happy to talk to anybody. Thank you.
Bye-bye.
Thank you. Bye.
Take care.